All right, so we are now live on YouTube. So welcome everyone who's joining us on the live stream. I'll just go and put up some announcements in various places as to the URL of the live stream. Now I need to find my own posting on here. On Facebook. Okay, and let's put it up on LinkedIn. All right, so we now got it up on LinkedIn, and I'll pop it up on the discuss pages as well.
Hello, can you hear me?
Yes, hello everyone.
Okay, perfect, thanks.
Can hear you fine. All right, we've started the live stream, so feel free to pop the link to the live stream anywhere you wish. That can be public. The link to the Zoom call itself isn't public because we've got limited number of people we can have on the call. So you please don't post the link to the Zoom itself publicly, but the live stream you can publish to your heart's consent. So I've just given a link to it there in the chat. Feel free to tell all your friends that they're very welcome to join the live stream.
Guess we should put this in the partners channel as well.
Yes, although they can, of course, all the partners are very welcome to join the Zoom call. And let's go and pop that. Welcome, Randy.
Oh, good morning.
Let me go and find the partners channel.
Hello.
Hello.
Is that Craig?
That's Craig. Morning all. Gonna add me as a co-host, go for it.
I will indeed. And Craig, there you are. And now I've got to do that as the main admin. Let me go and do that now. You are now a co-host, Craig.
Okay.
And let me get the link to, let's see. Pop this in the partners on Discord. All right, so I'll pop that in the partners chat. So we just sort of, the conference itself doesn't start, the welcome doesn't start for another 10 minutes. So all right, that is all ready and going. For those who are just joining in the live stream, we're just in the pre-conference stage. The conference itself doesn't start for another 6 minutes, and that'll just be the welcome. And we don't start the actual talks for another 35 minutes. But feel free to use this opportunity to chat among yourselves and ask questions in the live stream. So there's a...
Then I'll use the opportunity to brag a bit. We're working with system identification. We have doing some really nice progress. We're developing process and documentation on how to use system identification from start to finish. So it basically, it's 3 log files and spits out optimized PID for roll, pitch, and yaw.
Ah, very nice. Okay. What vehicle type are you targeting?
And you can define what kind of margin gains, copter. So any copter, we're doing for quadcopters and octocopters, but it can be used for any copter. And you can input stuff like what kind of phase margin you want, what kind of noise immunity and disturbance rejection. You can input how noisy are your sensors. So so it also tunes the notch filter and the low pass filters. And it basically uses a multi-dimensional solver from MATLAB to optimize for all these different things that you input, all these constraints. One of the constraints is also very important for newer copters that have problems with S desynchronization. Some of the copters are, when you tune them very aggressively, you can end up causing motor desyncs. And so one of the stuff that we also input is what bandwidth do you expect from your asks, so that the PIDs are also band limited and don't end up causing motor desyncs and stuff. And we have very, very nice results so far. But we are not finished yet, so that's why we are not publishing or giving a talk at the conference. But I hope that
so how will this be?
Talk about that.
How will this be given to users? Are you going? Is this going to be like a standalone program that takes a log file? Is this was this written like in Python or C++ or?
No, this is MATLAB. This is fully MATLAB, okay. And a set of procedures. So what kind of steps you need to do to get from one to the next, and a set of MATLAB scripts. And
if it does work well,
open source this.
Yeah. So MATLAB would be great for prototyping it. For wider use, it'd be nice to people not to have MATLAB. And so it could be done in, for example, Octave, or done in Python, and you could build it into Mav Explorer, you could build it into Mission Planner. But the matter of testing it first to make sure it works well on a wide range of vehicles.
Yeah, currently we're heavily relying on MATLAB functionality, on optimization, library optimization from MATLAB and stuff that I'm pretty sure it's only available on MATLAB and not in Octave. So,
but there's solvers. I mean, that you can, yeah, well, it's really just a solver.
A bit complex solvers, because we're you have the dynamic system with multiple inputs and outputs, and you're saying, okay, from this input to that output, I want whatever dB attenuation. From that output to the other one, I want that and that. So you're constraining a problem in multiple inputs, multiple outputs, and giving constraints on different things. So it's only a solver, but it's a complex one, and it's the input is also complex. And the way that we are inputting it on some kind of MATLAB scripting language, where
the MagFit is a multi-dimensional solver with constraints as well.
Function.
Yeah.
Okay.
Right, so I think it might be doable. Yeah, it's interesting. So I do think that making tuning easier for people is really worthwhile. I'm particularly keen on getting easier tuning for quad planes. So I'm actually working on a fast tuning system for quad planes. We've got the transmitter tuner, but I'm working on a Lua script that automates the manual tuning process of quad planes. Anyway, that's something that I didn't get it finished to present at the conference, but maybe for next conference.
Yeah.
But that sounds good. I'd be very interested to try it. And it's a matter of how robust it is.
Yeah, that's one of the things that all the users on the forums complain a bit, or they don't even complain because they don't understand the problem at all of optimizing PIDs and having to tune it themselves, and that every vehicle is different, and so on and so forth. So and this thing is we're basically we plan to give the Symlink model of ArduPilot, open it as open source, and open the documentation on how to do all the steps. But we're still figuring out how much of the MATLAB code are we going to give away in the end? So the first steps, yes. The other ones we're still working on it, but it seems to be very robust. Yes.
Cool.
And Randy, the customer for these optimizations is in Japan.
Oh, really?
Yes, it's the one that we talked a while ago.
Yeah, cool.
Yeah.
All right, so hopefully you can all hear me now. I've switched over to my other headset for the in my conference organizer role, and my audio coming through okay?
Yep.
Yes.
Excellent. Okay, so welcome. So we have a couple of minutes past the hour, and so this is the official start time for the conference, although the first talk doesn't start for another half an hour. But it's great to see so many people here on the Zoom channel, and I'll just go and have a look and see how many people we've managed to attract on the live stream. So I don't know how to tell actually how many people we've got on the live stream. We've definitely got a few because we had a few comments. So all right, great. So we've got a live stream. I'll just bring up my slides for the welcome. And so let's go and share screen. And hopefully you can all see that. So welcome to the Developer Conference 2022. I'll just turn off my other video on this other screen, and there you go, that's better. All right, so welcome to the Developer Conference 2022. And as you may have noticed by now, it's online again this year. And we had made that decision a few months back when Omicron was really surging and it looked like travel was going to be rather difficult. But I think it's been a good idea for it to be online again, and it's great to see so many people on the Zoom call, and hopefully we'll get a lot of people on the live stream as well. Now I will just start the recording. So we're going to record this call. So just give me a second and I'll start the recording. All right, so we're now recording, and so all of the sessions for this conference are going to be recorded and then popped up onto YouTube, and so made available. It'll take a day or so to get the videos up after after the end of the conference. I might be able to get the sessions from today up later today, but it does take a little bit of time for it to be processed. And so I'll just start with an advert for next year's conference. At this stage, we're planning to have the conference in person again next year. And so this is now the third year in a row that we've gone online only. And we still have our pizza conference dinner that was paid for back in 2019. And I confirmed last week with the wood-fired pizza place that indeed the pizza order is still valid, and that they're ready to deliver our pizza and desserts and antipasto and a whole lot of other things for a pizza feast. And so that's going to be, the conference is going to be on the 31st of March to the 2nd of April 2023. And we've got the hotel booking, etc., all done there. So put that in your calendars, ready for next year. We will certainly try to make it a combined online and in person for next year. So we will try and make it available, we'll live stream it, and have recordings and allow people to come in via Zoom. Exactly how we're going to organize that, we haven't worked out the details yet, but that is the plan, to be able to both live stream and have in person. So for this year, we have a great schedule lined up. So this is the schedule that we have for this year. So you can, if you've got your favorite talks, make sure you're around for them. It's really good to have a live audience and not just, and to have questions. The conference, we called it many years like an unconference. It's deliberately not a very strictly organized conference. We deliberately have the audience asking questions and interacting with the speakers. So you should expect that if you're a speaker. And so we're starting off with William in about 20 minutes time, starting on the BlueOS companion. William, are you around and ready for giving your talk?
Yes, I'm here.
Fantastic, welcome. Then I'll be giving a systems update about everything that's been happening at sort of the low levels of ArduPilot. Moving on to Randy with a rover boat update. If any of the speakers want to modify their talk title, feel free to do that, and just let me know in a PM or in the conference chat channel. Those of you who haven't noticed, we have a conference chat channel on the ArduPilot Discord server, and you can have sort of general discussions about the conference. Feel free to ask questions there, or discuss topics or put in links related to the talks. So after Randy, we'll have an ESP32 update, and that will end today's sessions. So we've got Nick. Nick, are you around? You're ready to give your update on ESP32 later today? I think Buzz will be helping you with that. Okay, we don't have Nick at the moment. Hopefully he'll be around later, ready for his talk.
Tridge, do you mind if I'm adding something here?
Yeah, sure,
dates,
Tom.
Yeah, the dates on there. Keep in mind, everyone, that the day of the week is actually Canberra time.
That's right, yes. It is noted at the top of the page, but yeah, you're absolutely right. So it is, in fact, still Thursday in the United States. They're always behind over there. So it's still Thursday evening in the United States. So you've got to, adjust the day on the schedule to, it is all relative to Canberra, the center of the world. At least as far as ArduPilot's concerned, that's where we hold the conference. So we're using Canberra time zone as our primary time zone. But thanks, Tom, for that reminder. All right, so today we don't have an afternoon evening session. So we get a little bit of time for preparing talks for the next day in the afternoon. And then tomorrow we have both morning and afternoon sessions, Canberra time. So we have 4 talks in the morning, and then we have 3 talks in the afternoon, evening. So it's going to be quite a long and exhausting day with a bit of a gap in the middle to have some food or deal with, household tasks, that sort of thing. So you get a bit of time off. And then Sunday, we also have a morning and afternoon session, kicking off in the morning with Paul with his GNC update and finishing up with our roadmap discussion. And that'll go quite late. So it starts at 9 p.m. Canberra time, and which will be good for people in Europe, less good for those in the United States. Apologies for that. It's hard to have a time that's good for everyone in the world. But that's where we tend to have discussions about, what we're going to be aiming to get done over the next year. And, all members of the dev team will be very welcome to be involved in that discussion and to put up what they're thinking of doing over the next year. We sometimes have pledges where developers say, what they're planning to do or make promises about their planned development over the next year. And sometimes those pledges even get done, which is always nice to see. So that's about it for the sort of administrative side and what's coming up in the conference. So any questions at all about the, sorry, I had one more slide, sorry, about the live streaming. So the conference is live streamed. And there's links on Facebook and discuss.ardupilot.org and Discord, and we've already got some people joined the live stream. Feel free to share the Zoom link with your colleagues, but don't share it publicly. Feel free to share the live stream link with anyone. We had, in the first time we did the Zoom conference, we got Zoom bombed because the link was public, and we ended up getting hundreds of people coming in and posting horrible links to things. So we're trying to avoid the Zoom call link being made public. But the live stream link, feel free to share it with anyone, and putting it up on social media and making people aware of it would be great, because we can have as many people as we like on the YouTube live stream. The timing for the talks is a bit approximate, so if you're scheduled to give a talk, try to get here a bit early before your talk is due to start, and be ready if you're up next. We may also just have gaps. If a talk finishes early, there may be discussions or a gap. As I said, that the conference is deliberately fairly free-form and not too strict. So feel free to ask questions and to have a bit of discussions going on around the talks. The slots for the talks are generously sized, so we can have plenty of discussions around each topic, and hopefully the speakers will be able to answer questions from the audience. All right, so any questions at all about how the conference is organized? Or disorganized, as the case may be. We're going to have
one thing. Sorry, we got a request on the YouTube channel to our YouTube stream to try and make sure that the presentations are available. So of course we have a very good idea. So maybe I'll try and collect up links or PDFs from the various presenters. I guess my point is, if we all agree to that, if you're happy with that, if the presenters are happy, sharing their slides, if they could, send them maybe some.
I think that's a good idea, and I think we should probably put them on the discuss.ardupilot.org conference page. So we have, if we have a look at the discuss.ardupilot.org and have a look at this developer conference one here, I think putting links to your slides in the chat here is probably the best method. And so I can start off I can put links into, yes, I can log in with my GitHub account, and I normally don't log in from this computer. I'll organize that a little bit, but I'll pop that up for my one. If everyone could put links there, you could put it in after you've given your talk or before, whatever you like. Just make sure it's a read-only link to your slides. We don't want people going and defacing slides. So when you share the link, make sure it's read-only. So I will now pop mine up. Links to my systems update talk slides. And let's pop that up there. All right, there it is. So there's a link to my slides. If anyone wants to see them, know what's coming. So if you're a speaker, please add a response in there with links to your slides. Can be done either before or after your talk, whatever you prefer. And that should help everyone be able to see what's in the slides. And you putting a link in the chat on the Zoom call can be a good idea as well, so people can follow along the slides directly. Thanks for that, Randy. All right, so is there anything else we want to cover before we just go to general discussion before the first talk? Nope. All right, everyone happy? Okay, so in that case, we can call this first session complete. And so we'll just have sort of general discussions among yourselves for the next few minutes before we start William's talk. And so we were having an interesting discussion just at the start there from Amilcar about some work he's doing on system identification. So Amilcar, feel free to continue that. And what's the timing for when you think you might be making that available?
So we hope that around the end of May, we should have it on the wiki.
And are you looking for people
so
to
that
test
anybody
that?
can, to reproduce it and to test it, and to get a bit of review as well. So we are discovering we'll be disclosing step by step how to do the procedure, so that you can system identify your copter, build a model, a mathematical model of your entire copter. A part of it will provide the Simlink model of the ArduPilot code. We already have that. And then using the system identification flight modes, with some flights that all you need is to switch ArduPilot to system identification flight modes, and then fly for around 1.5 minutes. And that's it. You have then fully identified one axis, so pitch. So then you land, you repeat the same flight for roll, and repeat the same again 1.5 minutes for yaw.
Presumably putting in some significant activation on that axis.
Yes, of course. We'll also explain what kind of amplitudes, kind of what is to expect. Right now, the documentation just says you have to put an amplitude between 0 and 1. And we want to at least say, okay, if your copter is like this big, you should put an amplitude of, I don't know, 0.4. If your copter is like this big, put an amplitude of something else, so that at least people get the guideline. Because right now,
so for when people go to enable this,
put an amplitude between 0 and 1, and that's
you're imagining that they would just load the parameters and the new parameters and go fly. It might be an idea to be able to switch on the new parameters using a switch. So if you could have a Lua script that has the new parameters in it, and then you a 3-position switch, at the bottom position, it's using your existing parameters, middle switch position, it switches to these new set of parameters, and you try them in flight, make sure they're okay, and the top position could be safe to save those permanently.
Well, at that point, you do not have any new PID. So the first step that you do, all you need to do is to activate a set of parameters that activates the system identification. You still are flying.
Oh yes, I mean, once you've run the MATLAB script and you've created the new set of parameters, having a way to activate those in flight, so get up to a safe altitude and then activate them,
that could
be very powerful. And that would, because I imagine there will be cases where these new parameters are not good for the vehicle, and that where the automatic tuning has failed in some way. And so being able to, I'd be more confident if I could activate those in flight. And I think having a Lua script where you have like a table of new parameters that gets generated by your MATLAB script, and then being able to switch that on and off. It could be done as just a file.
Nice.
So we could have a helper Lua script as an applet, which reads off the SD card new palms, file, and then activates it with a 3-position switch, off, on, and save. And save would mean that they're activated then permanently.
That could be useful for all kinds of parameters.
Yeah, that's right.
What parameters specifically are we talking about changing here? What is being identified?
The model of the entire copter. So basically, you're identifying the response, the dynamic model of your ESCs, your motors, your propellers, your battery system. So your entire propulsion system, you're identifying the differential equations for that. And then you add the differential equations of the PIDs of the software, and you have the entire closed loop. And then you can go and say, okay, I want to optimize this closed loop, and I want it to have this kind of response. So you give him some some limits and some optimization where you want to go, and then it spits out a parameter file with all your PIDs optimized according to your desires.
How does it handle noise limiting? I mean, often PIDs are not based solely on the dynamics of the vehicle, but they're noise limited, right? So you can't have too high a D gain. You might want to have a high D gain. I'm sorry?
Yeah, so in this case, that's a very good point. So in this case, what we do is that we tell them at this input, we have sampled the noise, and we know that we have this kind of noise at this input. And we want between the sensor input and the PIDs, we want to have an attenuation of 60 dBs at those frequencies. So you actually specify the Bode diagram.
Okay.
So
it'd be interesting to try
what kind of frequency response you have from your sensors. And then it goes in there and changes all kinds of parameters on the Simlink model of the code until it gets it right. So it actually doesn't know what the filters are. It just goes in there and changes the parameters so that it can fulfill that goal. Yeah.
When I did system identification up and made this mode, this is exactly what I was expecting to happen sooner or later. So from my perspective, it's really good to see somebody doing this. So thank you.
Yeah, well, really interesting to try on a range of vehicles, and on real vehicles, a bit, you know, from little racing quads up to, you know, big heavy vehicles. Be really interesting to try, but I think it will be a lot safer if we had that mechanism for engaging the parameters in flight. And we can do that as a general mechanism where it can engage all sorts of parameters and, you know, set and then save. That would, I think, be a generally useful Lua script, not just for tuning parameters, but for other things as well. So you can try a new set of settings.
Yes.
No good for settings that require a reboot, of course, but you know, rebooting in flight is something that we have done, but generally is not recommended.
Yeah.
Yep. Good stuff. Well, that's really exciting, Amilcar. So hopefully you'll have that, give a really good talk about that next year at the much more detailed talk with demonstrations. Yes. Yep, and maybe it'll be all produced. I'll be interested to see whether it works at all for quad planes, because the extra aerodynamic drag of quad planes makes tuning a little bit different.
Yes, so that's a difficulty on this model, because we're assuming certain properties that you have on quadcopters and octocopters that you don't have in quad planes. So the modeling for a quad plane needs to be reviewed, but that's something that we are describing, and it should be easy for somebody else to change that, or we can work together with other people and change that for a quad plane.
Well, let's try it in multi-rotors first and just see how well it works over a range of multi-rotors, and particularly ones that may have significant vibration issues. I think that'll be interesting to see how well it works for those.
Yes, those are the more demanding types. Yeah. And Leonard, thanks for all your work. We are really appreciate for the work you've done on system identification, and we hope that we can continue your work and that everybody can profit from it.
My pleasure, mate. The system identification mode is just the small little easy bit at the front. So
yeah, I know the stuff that when we started it, I was like, okay, 4 weeks and we'll be done, and that was like 4 months ago. But now we have some very, very nice results. We can really explain what we want, and the system really optimizes that and gives us what we want. So it's really nice, and really nice the fine granularity that you can actually explain exactly what kind of margins, what kind of gains you want, and it gets it done. It's very nice.
It'll be very interesting having another reference to compare back to results of auto tune for both the heli style auto tune, if we end up with a model for helicopters as well, and for Yeah, the standard auto tune
one of-
operators.
So one of the things that we did was that we grabbed the normal copter, relatively small, and with standard parameters, and we run system identification on that with no previous tuning, just normal tuning, and then we plotted all the graphs, and we did the same thing for after doing auto tune, and we did the same thing after optimizing the PIDs with these methods. So you can see the three graphs with different colors, where you can see, okay, the standard parameters, the control loop is stable, but it's not perfect. And then you have the auto tune, it's better. And then we have our method that it's a lot better. So you can see that on both diagrams, and you can see that also on step response. So yeah.
I'd be interested to see those results.
Yep.
Separate, I've been slightly less complex. I'm working on a Lua script to automate the manual tuning steps, where you sort of raise D until it oscillates, then back off, raise P, oscillate, back off, that basic, manual tuning process. So I'm working on a Lua script to automate that. And just to get an initial tune on quad planes to make that process, because it's I don't think it's going to be hard to get that quite reliable as like an initial tuning system. Should work on copters as well. Won't be nearly as refined as as auto tune or the work that Amilcar is talking about, but should get us a fair bit of the way there for get the tune in the right ballpark.
Yeah, Yuri's written one of those apparently for rovers as well.
Right, nice. Yep.
Pro users or pro testers.
Excellent. All right, so it's just about time. So shall we start a couple of minutes earlier, or any more sort of general chat topics before we get going with William's talk? It's really great having these sort of general discussions, and thank you very much, Amilcar, for bringing up that project. It's nice to sort of hear that things that are coming up in the future. And so if anyone does, in the gaps between talks later in the conference, have something they'd like to do, like a little lightning presentation on or discussion, that would be most welcome. We don't have to stick strictly to what we've got in the schedule. Okay, I think we'll start with William's talk now. So William is a long-term contributor. So actually, I'll just make William a co-host so we can actually do presentations. There you go. And so William's been a long-term contributor to ArduPilot, and particularly in the area of sub and blue robotics, but he's also the developer and maintainer of the plot.ardupilot.org, which is an absolutely fantastic plotting tool that is becoming more and more popular. And also he was the one behind the user interface for our the new user interface for our terrain server. And so, William, thank you so much for all your development you've done for ArduPilot over the years. And now over to you for your discussion of the BlueOS companion system.
Okay, thank you. So, hello, I'm William.
I'd like to turn on video and screen share.
Yeah, just a sec. Not sure if video is going to work.
That's it. Your video is working.
There you go.
Great. Let's see if screen share works.
No. Yeah, that's tricky. I'm gonna have to share the whole desktop. Okay. Can you see it?
Yep, that's great.
Nice. Cool. So yeah, I'm gonna talk about BlueOS. It's the new companion system we are developing at Blue Robotics. So let's start at why we need it. So our old companion was forked and heavily modified ArduPilot companion. ArduPilot companion is a repository that's been dead for at least 2 years. It was, I don't think there was actually anything original there from ArduPilot companion, but it was a fork. It was pretty hard to maintain, update, and integrate things into it. There were there was a lot of like monolithic pieces of code and things. So Sub relies heavily on companion computers. We need an Ethernet connection for video streaming. It also does the pixel flashing because it's usually inside an enclosure, and so the pixel is hard to get to. It handles like joystick inputs, and since the pixel is hard to get to, it's also responsible for fetching logs. And we also use a lot of different third-party sensors, some that are not ArduPilot specific, like DVLs.
You just started talking to me when I was in the kitchen.
And,
I thought you were in the bathroom here.
And
We get some extra audio from somebody.
Yeah.
The mute.
So we have lots of third-party sensors that are integrated via the companion computer. And also integrators need an ecosystem where they can easily develop their own integrations to like in a maintainable way. Right now, people just fork our companion and it's pretty messy. There's no properly way of doing it. So what was our approach? We chose to go with containerized components and services. So we can like restart and update containers with a very low risk of needing to reflash the SD card in case something goes wrong. So it's very hard for something to go wrong that bad, so you need to reflash your companion SD card. This way, integrators can design their own systems in their own separate containers that runs besides our container, our Docker container, instead of forking the whole system as it is today. And this way, dependencies are isolated, so individual services don't have to compete for dependencies.
William, we have a request for you to turn your mic up a little bit, if that's possible.
Yeah, let me check.
We're having a hard time to hear you.
Okay. Let me check if I'm using the right one. Yeah, it should be right. Oh, this is not right. Hello? Is this better? Hello?
It's the same.
That's pretty clear
It's
for
the same
me.
for me.
Yeah, I'm not a big fan of Zoom, and this is one of the reasons. Okay, I'll just speak a bit louder. Is this good?
Yes.
Okay, so we chose to go with a web interface and web APIs. So our core interface, it's like a consistent piece of code that is able to control and display all the active services on the system, including third-party services. We have a section, we'll see it later, that just shows all the services and all the documentations found. We're working on having a dashboard on the main page so people can add widgets for third-party services and our own widgets there for important pieces of information all in one place. Our API structure allows services to communicate with each other. And we intend on building a web store so people can share extensions. So our integrators can design a piece of code for maybe integrating a sensor or adding a new functionality and publish this in our store. So for the front end, we decided to go with Vue.js and TypeScript. It allows for really very reactive components. See the heartbeat icons in a sec. We use Vuetify to make it look good. And it relies heavily on Mavelink to Rust Mavelink that was made by Patrick for integrating Mavelink to the front end. So you can have lots of Mavelink information on the front end. Our backend is using Python 3.9, which should upgrade to 3.10 soon. Rust is used for developing some of the critical systems. And we use Mavelink Router for the Mavelink routing. But we also support Mavproxy backend. So let's get started. To the left, it's the main interface you'll see when you open the BlueS. At the top right, we have lots of little, okay. This is a GIF, so it's a bit hard to follow. Let's follow the GIF. Let's wait a bit. And now we start over. So, okay. There we have lots of small pieces of information for the stability of the system, temperature, voltage, Wi-Fi controls, Ethernet wiring controls. We have also the notification system. We have lots of Wi-Fi information there. We can control wired interface, set static, dynamic IP addresses. We can now force fetching, getting a new DHCP lease. This is the main menu. We can power off, reboot, restart only the container if you want. As a settings, we have this pirate mode, which enables advanced functionality for advanced users. So like our basic user should be fine without pirate mode, just for piloting the ROV. And developers will likely want to enable it. We also have this at the bottom right. We have lots of warnings when things go wrong, like high disk usage, high CPU temperature, when we lose Mavelink heartbeats for some reason, like the Autopilot died or something. So this is an overview. These are all the features we have right now. I'll go through each of them in the next slides. The Autopilot section, we can change boards if you have multiple boards connected. This is a very developer-focused feature. If you have multiple boards, you can switch between them or even enable zero. We can fetch repository from the manifest and ArduPilot servers. You can upload a custom firmware file, or you can restore the default file that we have embedded in the BlueOS itself for when people have no internet, which is often the case for ROVs, as people are in the middle of the ocean. Oh, this did not work as expected. Okay, the log browser shows all the logs from the Autopilot. It's able to replay the files in log viewer. It works completely offline as well, so it's embedded in BlueOS itself. You can also delete logs, download them to your computer. And we are working on downloading logs from a Pixel via MavFTP, but that's not ready yet. Next section, Mavlink Endpoints. So here you can create custom Mavlink endpoints, so you can connect additional GCSs, components, or scripts. You can individually enable or disable each endpoint. And it's analogous to Mavproxy's --out, where you can send strings to different places. And as the other services, this also has an API for easier integration. Next, video streams. So this was mainly developed by Patrick as well. This is a Rust service that detects USB cameras capable of streaming. Right now, it's only H.264, but we are working on it. This also exposes the VFRL configurations, as you see now, all the brightness, contrast, filters, everything from the camera. This string can be either UDP or RTSP. And for developers, we also have a fake source option that just generates a fake stream in BlueOS itself. This is the famous GStreamer video test source, where you have like a ball going around the screen. We just finished integrating WebRTC because we intend on adding GCS capabilities to this with video streaming. Okay, next section, available services. Oh, these GIFs are not helping. So we have a section that shows all the available services. This is it. Here you have the address, the documentation address, and if the documentation is, the API is versioned, you have the versioned link. We are using Swagger UI to show all the Open API options, and you can actually test all the endpoints here. This is the result for this endpoint. So the idea is to be very developer friendly so people can develop happily. And this is like the unified place to looking at our APIs and what's going on. Next. Okay, so these are all the services we have right now. ArduPilot Manager is the backend responsible for managing the Mavelink streams, and if I'm not mistaken, doing the firmware updates. Beacon is a new service. We developed it for MDNS publishing, so we can actually do BlueOS, .Wi-Fi, .local, etc. We had to develop it because Avahi was just not doing the job properly. This is the front end. Bridget is the one responsible for doing serial to UDP bridges, so we can connect serial sensors to UDP streams. Cable Guy is responsible for our cabled Ethernet management. Commander is a service that is able to run commands in the host system. So if you need to escape the Docker for some reason, you have to talk to Commander. File browser is our file browser. Camera manager we already talked about. We also have Mavelink to REST running that also has a nice Swagger API running, Swagger UI. We have an Nmea Injector that's used by, well, I'll get there. It's used by external GPSs. Pardal is the guy that does network speed test. We have a guide that shows system information, a web terminal, version chooser for showing versions themselves. This is an experimental service. Waterlink DVL is an experimental third-party integration that I've been working on for integrating a DVL. And lately we have the Wi-Fi manager that is the backend for managing all the Wi-Fi connections. Okay, next. So, bridges. This guy, as I mentioned before, is able to bridge serial ports to UDP ports. Think of it as sockets from Linux. This is already used under the hood to power our sonars. So both our Ping1D and Ping360 are using it. Ping1D is a regular sonar, just a pinger that measures distance. And Ping360 is a scanning sonar, so it does a full 360 sweep. Both of them are connected via USB and have an UDP port assigned to them so that we can talk via our Ping viewer. That's our interface for viewing sonars. But this should work with any serial port as long as you have on the other side something that can talk to UDP. This is also made in Rust, by the way, and by Patrick. Okay, we have a file browser. It makes editing files a lot easier. You can look at all your config files. You can change files if you want. If you want to tweak a service to test something, you can do it here. These changes are not permanent because it's running in a Docker container. So you would have to do a Docker commit in order to save it. And this is, yeah, very useful for development. You can, for example, when running ArduPilot Linux, you can reset the storage file and do some weirder things. Not that I recommend it, but yeah, it's useful. Okay, the Nmea Injector, we have this guy for taking Nmea strings via UDP and then converting them to GPS input Mavelink message to send to Autopilot. This is the way some underwater GPS integrations work, like the water-linked underwater GPS. I think Cerulean as well. This is like a generic approach for implementing this GPS functionality on ROVs, because water doesn't allow GPS signals to go very deep. So
just sorry, it's Randy here. One problem though I thought with the Nmea method, or sorry, the Nmea GPS is that they don't provide velocity. I wonder if those underwater GPSs can provide velocity, and if we're throwing some data away.
In my experience, the underwater GPSs are not very accurate at all, so I don't think that even makes much sense. I don't think they can. I haven't checked properly. So for velocities, people usually use DVLs, which are Doppler velocity loggers. Any other question?
Sorry, actually, I have just a random question. So you just mentioned what, DBL or something? Is that like
DVL? It's a Doppler velocity logger. It's a sonar that has usually 3 or 4, I think, transducers, and it checks the difference in frequency, like the Doppler shift from the reflected signal when a vehicle is moving. So it can very accurately measure velocity in water, as long as the seafloor is in the range.
Right. And I guess I can ask you offline. I've never actually heard of that before, but sounds a bit like flow for submarines or something. But I guess it only works in the direction, like optical flow works horizontally, assuming that the camera's facing down. It's like, I guess this would work only when you're facing the thing, so it could tell like how quickly you're moving up and down if it's facing down. Is that the idea?
Yeah, we can talk after the presentation, but it's usually facing down, so you are able to hold position in X, Y, Z,
really?
As long as the ground is there. But I can show you some videos after this presentation. Yeah, the DVL integration that I have in development is not using GPS messages. It's using the visual odometer message. So it works. It doesn't have an absolute position because it only measures velocity. So it's a bit different. Okay, I think I'll go on. So we have a whole section for system monitoring. It shows all your processes, all the information in DMESG is there. So all the kernel messages, some general about version as well. We have all the processes. It's very similar to HTOP. So you can see here that I'm running ArduPilot on Linux. Some overview of networking as well. And that's it. This is just for system monitoring and debugging as well. Oh yeah, I forgot I had it larger. Yeah, I think I'll just go on. Okay, we had a network speed latency test because for ROVs and other vehicles that use IP connection, the bandwidth is, especially if you have video, the bandwidth is critical. This is also used for troubleshooting in ROVs, for troubleshooting tether issues, connection issues. It measures your upload, download, and at the bottom you have the latency, the little clock. That's the latency between your browser and your companion computer. We'll probably make one of these for the internet as well. We also have a terminal. We have a terminal in the web itself, the web UI. This has Tmux. It's a Tmux session by default. You are able to exit the Tmux session to get into the. I mean, you are able to escape the container and get into the Pi itself if you want to make permanent changes or something like that. And here you can find all of our services and all. You can kill any of them, restart any of them in a very easy way. But yeah, with great power, you can break things. But that's why this is also only available in pirate mode. So we also have a Mavelink inspector. You can look at all your Mavelink messages. We have some special handlers for some of them, so we have some more of a human readable output. At the right, you can have all the raw data. This is similar to probably other Mavelink inspectors you've seen before, like Mavproxy Watch or the Mavelink inspector in QGC. We'll probably get some live plotting going on eventually, but it's a work in progress. And this is kind of a critical section. This is the update system. It's completely based on Docker. It has two interfaces. There's a simple interface when you don't have pirate mode active that is very simple to use. When you open BlueS for the first time, it will check if there's a new version available. It will show you this message anytime now. This takes you to version chooser, and you can just click update there. And that's it. And then we have the more advanced version. As soon as the GIF restarts. But this is for advanced users. You can switch to any version. You can switch to your own Docker Hub remote if you want. You can upload Docker image files manually. And yeah, we have to wait a bit now. So if an integrator wants to do some changes and he really doesn't want to use hardcore, you can just switch the remote versions down there, and it will just start using their remote, and that's it. There are no complications. So here I'm switching from 1.0 at Blue Robotics to my own. So I just write my remote here. It finds the messages, and I can download and apply it. And that's it. After this is done, there's a new image, and I'm running the new image. And this will only, even if the process fails right now, it's only pulling the image. So there's no way it can be broken, because the image is only saved after it finishes downloading. And we also have some other contingencies in place. For example, if someone builds an image that doesn't have this interface for changing versions working properly, we have a guy that's just checking every, I don't remember the time, but it's periodically checking if this interface works. And if it doesn't work, it reverts to a factory image that's not work. And we also have some other planned features that we haven't finished yet. We have actually already a pull request, like a work in progress for parameter configuration. On top of that, we want to make customizable vehicle setup for individual peripherals. So for sub, we want to have individual tabs for, let's say, gripper, camera setup, lights, and now even DVLs and other stuff, we want to have individual tabs to control each of them in a very user-intuitive way. We are working on an onboard vehicle control software, GCS, that's web-based, including video, joystick support. And we want to build a widget-based display. So we want to allow third-party integrations to build widgets and overlay that on top of the video. So they can basically do whatever they want. We are also working on having onboard video audio recording, because right now it's on the top side, with our current solution. And doing it on board will also allow you to have more cameras in there. Okay, custom extensions and the store, as I mentioned before. Another big thing that we are working on is multi-source logging synchronization. So we'll have multiple video streams, we'll have data flash logs, telemetry logs, logs from sonars and other sensors from users, and we want to be able to centralize this somehow and replay this all synchronized, the video, the replay data, the sonar data, everything. This is it's a big deal, especially for people doing inspections and similar things. We also want to get some debugging tools in there, like a GDB server for when you're running ArduSub on Linux, maybe OpenOCD for other boards. We want to support multiple boards. Right now, we support some Raspberry Pis. Our software is pretty agnostic, but we have some limitations yet. And also web Mavelink console, so you can just send whatever you want to your vehicle. So this is our built-in GCS prototype. It's running on a phone with a Bluetooth joystick and connected to a 5 gigahertz Wi-Fi. I also have a video to show. So let me find this here. This is a video of the same day. This was recorded on my phone. This is just a very crude prototype, but we have Mavelink data, we have joystick control, we have a fish I'm pursuing. More like stalking. And I think that's it. I'll just keep this video playing for now. Any questions?
It reminds me of playing Doom or Quake. You know, the thing is the arm out the front and wandering around. And,
yeah, I haven't tried Chainsaw yet.
Absolutely fantastic. That's really, really brilliant. Thank you so much for the. I'll just turn on video there.
Oh, I think actually there's one last slide, I think. So you can try it. We have a download link that will be in the slide. I'll share as PDF. But if you go to this repository, you should be able to find something. The images are available as a GitHub release, so you can just download the image and flash it to a Raspberry Pi. Another thing to note is that we are focusing this right now on Sub and Rover, but we would love to support other vehicles as well.
So that's absolutely fantastic. Thank you so much for that, William. And customizing it, I mean, is it possible to skin it so to be suitable for different vehicle types and different vendors? So like a partner might want to make a version that's suitable for their vehicle, and they might want to use a different theme instead of sort of the pirate theme that goes so well with nautical applications. You know, they might want to have a different theme to that. How would they go about theming it and skinning it for their particular use case?
Yeah, this is not ready yet, but it's a planned feature. I forgot to add it there. But we are thinking at exactly that. So Blue Robotics builds a lot of components. Actually, we have lots of companies that use our components to make different ROVs, and we already thought that someone would want to customize it, so that's already planned, at least colors and a logo.
And would Blue Robotics do consulting for partners who want customizations and adding features and things? Is that something that is within what Blue Robotics could do?
It hasn't been discussed yet, but I think so. We can talk after this.
I could imagine that some partners might find this, really quite a compelling capability, but they'd want to, customize it and have particularly their own sort of imagery and branding and things on it, and adjust the features to be suitable for their vehicle. So open the floor now to questions from anyone. So questions and comments very welcome from anyone in the audience.
Yeah, quick question here. How long till we can fly a plane with it?
Well, we haven't tried. I don't have any planes right now, but I think it should work.
If we send you a Bixler, will it happen?
Maybe. I'm open to trying it. I haven't flown planes for a while now. I mean, the good thing about ROVs is that they never fall out of the sky.
they can get wrapped around wharves, though.
That sounds like a challenge to me. Can you send one over?
So I have a question, actually. I think you were mentioning that you were going to work on, uploading files to the cloud, like onboard logs or something. Did I hear that correctly?
Not in this presentation, but we have to work on downloading logs from the Pixel via MavFTP. But probably later on, we'll develop a whole cloud side from this for uploading logs and log analysis. Especially after the log synchronization thing is done, we'll probably have a cloud backend for storing and replaying it.
Since you say, sorry, Randy, go on.
Yeah, no, I can just imagine that, a bit like boats, obviously I do a lot of boats, and one of the issues is that you build up a lot of data on the log, on the companion computer. And, it's a mess to get it off of there unless you've got some service like what you've got here. So it sort of fits in well, I think. So I can imagine, you're thinking about that.
Yes.
But I don't think you'd want to download the logs via MavFTP. I think it'd be better to stream the logs live using the Mavelink support for streaming our logs to the companion computer, and that way, and then upload them from the companion to the cloud. Otherwise, it can take quite a long time to download that from the flight controller to the companion. You don't want to have to sort of sit the vehicle and leave it alone for a while to do that. It'd be much better if the log was already there by the time you finished your mission.
Yeah, that's a very good point. I'm not sure if that was broken in Mavelink router, but yeah, we'll have to get back to that.
I know Peter's been doing a bit of work on that lately, and there are a few partners who are using that, the streaming of the logs directly to a companion. But that would be an important feature in something like this, I think, so that all of the logs get automatically archived onto a cloud server without the user having to do anything.
I am keeping an eye on AP Cloud as well.
Mm-hmm. Yep.
Arpanion and AP Cloud have recently integrated. So that's Steve and myself got together and made sure it worked. So,
cool.
It's
nice.
It's going in the right direction.
Awesome. Yeah, it's going to take probably a few months before we start working on any cloud thing, but we should stay in touch.
Yeah, I was wondering about where you're drawing the lines on the application. I noticed there's a bunch of different different things that it does. For example, like you can do the companion computer setup and the setup of services and restarting services and all that kind of stuff. And then it also at the same time does, for example, of course, the firmware upgrade, that's obviously really important. But then it actually starts moving into kind of ground station features as well when you start doing like the log browsing on board and that kind of thing. I was just wondering, why you decided to go so far. I mean, there's obviously more is usually better, but at some point as well, you wonder why you use that instead of like an existing ground station which has some of that stuff already built in.
So yeah, we are not. We usually use Qspi, but we're not very happy with it and maintaining it. And at one point, we just decided to do our own things, and this way we decrease the amount of software in our ecosystem because we have only BlueOS and ArduPilot. So we don't have now a companion, a GCS, and a flight controller. We don't have the flight controller, and everything now is part of BlueOS, and it's completely under our control. So it's a lot easier for us to keep track of.
Yeah.
Making everything web delivered certainly has its benefits.
Yeah, a lot of our work on Qspi has been just maintenance and keeping things working, so it's a bit exhausting.
Yes, you want to have a very specific solution for your sub-users.
Yes. Yeah, it's kind of a very specific use case. So we had lots of very sub-specific things in Qspi as well. We also have some things in there that also were not done properly, so we want to do it properly this time.
Cool. And actually, I have just a follow-up question. One of the things that I guess, integrating with a sonar is something that I'm also interested in. So for example, you have like a flight controller, it's producing its attitude and position, all that kind of stuff. And you want to get that data somehow integrated in with a side scan sonar or a regular sonar. Right now, the only way that we can integrate those two, as far as I know, is to actually connect the sonar to the flight controller, and that's what I normally do. But then there's bandwidth limitations. There's only so much data that you can squeeze into a flight controller or send into a flight controller and have appear in the onboard logs. So the obvious solution I thought was to put that on the companion computer. And I'm just wondering, is that something that you're planning or is it already done? Maybe
I think this is in the log synchronization thing I talked about. For some sonars, so let's say a side scan sonar, that's a lot of data in there. We really can't store that in the Autopilot, like in the data flash. There's no chance. So we want to work on a solution that synchronizes all these log files and allows for third-party sensors. I'm getting some weird noises in here. Let's see if it was the video. But yeah, we want to work on a solution that integrates everything. And I'm not sure if this was your question, but for sending things to the Autopilot, in our current companion, we have a man in the middle that works between our ping viewer and companion. I mean, between ping viewer and the sonar that turns the data into Mavelink and feeds it to the Autopilot. But that's only for the depths.
Yeah, so you're saying.
I'm not sure if I answered your.
Yeah, that's a great answer. Yeah, I mean, I can sort of see that you're hitting the same issues that I've been hitting on the boat side, which is that you have this ton of data coming in. You can't put it into the Autopilot. You still want to make it visible to the pilot, though. So you need to get some like cut down version of that data, sent through the flight controller and then sent up to the pilot wherever they are.
Yeah, we have to send to the Autopilot only exactly what it needs. So like we can't have it processing everything. Our ping 1D, it's while we only consume the depth, it produces an array of data with
the backscatter data, right?
Yes.
You get a ton of You don't just get a single distance like a LiDAR, you get like a whole bunch of distances, and it's not really very convenient to handle that inside of ArduPilot.
Yes. One thing I want to try is I want to get our scanning sonar that's 360 in a plane, and I want to generate obstacle messages for. I want to see how that goes.
Yeah, either
maybe you can get some avoidance going.
Yeah, proximity sensor. Great.
Question.
Yeah.
Question. I missed it. What kind of hardware is the companion running on? Is it a Jetson, and how is it connected to the ArduPilot?
It's running on a Pi 4 right now. It works both connecting via USB to a Pixel or on a flight controller, or it can run ArduPilot Linux. We are working on a board that it's a Linux board, so it can just plug on top of the Pi. So we have both the flight controller and the companion at the same package.
So one of my other thoughts with regards to how this sort of applies to other vehicles is that you need a high-speed IP link to the vehicle in order for it to be useful. Rovers don't have that problem because they've got an Ethernet cable, and you've got 100 meg or gigabit Ethernet, and doing similar on a plane, you don't necessarily have that sort of link.
Yes. How is that done now?
These days, if you want a high-speed video link, you'd use something like a HereLink or a Chinese clone of it, and you'd get your video that way.
No, I'm wondering about companions. The way I see it, you could set it up on the ground and then just fly. We are working on it having a hotspot, so you could connect to the hotspot while on the ground and then just fly.
That's right. For aircraft, and a companion is usually more useful for configuration than it is for flying it through a web browser.
Mm-hmm. Yeah, so you could, yes, of course. By the way, this GCS we're working on is going to be a different system. So it's going to be one of those extensions we talked about. So it's not really required. We'll probably have a different one for rover, and maybe that one will be more plane friendly for waypoints and navigation.
Yeah, I think for planes, there is a lot for planes and multi-rotors and other flying things. There is a lot of data radios that you can get. You definitely run into the lower data rates, and certainly as you get to distances, you're running into like maybe 5 megabits per second or something like that. But it's enough to stream a good compressed HD video stream.
Yeah, there's quite a few
I did also have one
available now.
Yeah, you can put Ethernet directly through the HereLink as well. If you need an Ethernet link, obviously the rate depends on distance, etc.
Yes, but that's probably one of the few ones on the market that actually can do those sorts of bandwidths right now.
Oh, there's Doodle Labs and there's the Silvus and things. So there's all different price points with different capabilities, for ones. But the HereLink's obviously a really well integrated choice.
Yeah, William, I had one question about the kind of like the multi-logging streaming kind of system as Tridge was asking before about integrating data from multiple sensors. Yeah, it's definitely a problem that's come up a lot, and there isn't a one-size-fits-all solution really. I was wondering if there's any option, or if there's any kind of way to also maybe tie in with the video data as well. It doesn't come up a lot, but sometimes there's something really good in that FPV video footage, or maybe even in rare circumstances, some kind of outside video footage that's recorded.
Yeah, for ROVs, that comes up a lot. Yeah, that's one of our main goals, to synchronize data logs and sensor logs with the video, so people can. That has been asked a lot.
I want to ask one thing regarding this H.264 video transmit link. We are doing something very similar over the VPN, but what I faced is this: over the VPN, the H.264 have some issue with the MTU parameter of the VPN, like the image is graying out a lot compared to a normal image. Have you seen this kind of thing, transmitting H.264 over the Ethernet?
I have seen this on QGC. When you lose packages, depending on the camera, it kind of goes to a gray or silver image.
Yes.
I haven't experienced this with WebRTC, and you can see in this video there are no
yes.
green images.
I can see that. Yep.
There's actually, was this on QGC or what was?
No, we were using the mission planner actually.
Okay.
And even I've seen this thing over the Doodle Labs radio. When you run a Mavelink router over the, I'm sorry, when you send the H.264 first image over the Doodle Labs radio, I've seen similar, but in a much worse scenario. I dig deep into it, and what I figured out is a parameter called MTU. You have to tune MTU to some value. I'm not sure how to tune that. My actually question was if you know how to tune it properly. That was all.
Yeah, sorry, I'm not aware of that.
Thanks.
No problem.
Yeah, so MTU is your maximum transmit unit. And it's common that the different transports, if you've got a whole bunch of different transports, you've got Wi-Fi and Ethernet and various other transports, VPNs, etc., between the origin of the data and the endpoint, you often want to tweak down your MTU so that you don't get fragmentation of packets. And because the packet fragmentation can lead to less reliability. Yeah, it's quite common to have to tweak MTU. If you just search for, MTU adjustment on VPNs, there's quite a bit of information out there.
Yep. Thanks for that.
So, William, multi-vehicle support. That's something that's come up a lot with controlling, particularly multi-rotors and planes lately. Is that something you've dealt with at all with submarines? Have you thought about, one operator controlling multiple vehicles? And would that just be opening multiple tabs in your browser, or is there more integration for multiple vehicles in the control?
I think for ROVs, it's most common to have more than one pilot per vehicle, but this would probably belong to the cloud solution.
Right, so you're thinking more like the AP Cloud stuff that's being done by Hefner and by Buzz, and that's more the solution, you think?
Kind of. We're planning on expanding this to the cloud eventually, and then I think only then we'll be able to actually support multiple vehicles properly. But right now, if you have multiple vehicles and you open your tabs, you can control both with little issue. I mean, we don't have a way to select the joystick right now, but it's not that common in the ROV world.
I guess you'd need to set up the ports because you've got the one ground station multiple tabs, the UDP port numbers and things you'd have to separate out so that it can.
Maybe, I mean, probably not. The other web part is client, and the ROV is mostly the server, so you just connect to two servers.
Right. Okay. Yep.
And the WebRTC, the video is WebRTC, so that sorts itself out. And the joystick is WebSocket. That also shouldn't be an issue. It's a URL instead of a port.
So is the resolution of the video that's being displayed on the user interface, is that the same resolution that is actually being captured on the camera, or do you then record high resolution video on the vehicle for when you want to publish it later?
Right now, we do transmit at the same resolution that we will record, but we are planning on transmitting a lower resolution later on when they get hopefully a 4K camera. This is a full HD camera. So it's fine to transmit, but we want to get a 4K and we're working on it. So then we'll probably need to string at a lower resolution.
Right. I was also thinking about if you had outages.
But to be honest, the power resolution in the camera resolution in this video is from my phone. I just recorded on the phone because we don't have a recording solution yet.
And if you had multiple cameras on the vehicle, will it sort of be able to select between different cameras on the vehicle? I'm guessing it'd be fairly common in a ROV to have a like forward-facing and backward-facing and other cameras. This is
another request that we got often. So Mavelink Camera Manager already has support for multiple cameras. In Qspi, you can already switch between cameras using the joystick. So that's all in place. But as this is just a prototype of the WebGCS, we don't have anything like that yet. I mean, it's probably most of a UI thing, and the backend probably handle everything fine.
Do people do stabilized cameras on ROVs, or are they always just sort of fixed orientation?
Like they do stabilized cameras. One issue we have with gimbals is that we don't have a lot of space inside the ROV. Let me show you. Oh, this is a heavy guy. Can you see this? So the camera is inside this enclosure, so there's not a lot of room for like a brushless gimbal. Right now, we only stabilize pitch. But I have been experimenting with a brushless gimbal, but I haven't got anything good yet.
So you mostly would do the stabilization in post-processing if you want to publish a video, I guess?
I'm not sure it comes to that. I think the videos are usually not that bad. I mean, in this one, I don't think I had any stabilization on, did I? Yeah, just a bit. But I'm not actually sure.
Certainly for on copters and on planes, sort of controlling of gimbals and things would be quite important. So perhaps that would make sense as a plugin to be able to control the the gimbal pointing and the stabilization.
Is that usually done with points of interest or just manual control?
Depends on the application. Depends whether you're sort of surveying and you've got somebody actively looking at it, or whether you've got like a flight plan where you want to look at some particular points. Both are available, and you might have a button to switch between the different modes.
Yeah, what we usually use in the review world is that we have buttons. We use a regular like PS4 or Xbox joystick, and we have buttons that tilt the camera up or down. Because right now you can only control it up or down, so it's not a big deal. And I guess that roll and the yaw are mostly just stabilized anyway in most vehicles.
Great. All right. Yeah. Well, that's been absolutely fantastic, William. Any more questions before we finish up on that one?
Yeah, I just wanted to kind of clarify something a little bit, and I guess we're gonna have some more discussions about the cloud in later presentations from Buzz and others. But I guess one thing to sort of keep clear in your mind is especially like with this application, it covers like a lot of ground, and there's like the web ground station part, but then there's also like the whole companion computer setup, service management and configuration part. They're like two, in my mind at least, they're two very separate things. And the companion computer management part, I think, is actually the more like portable part. Like that's like kind of a general service that is really useful, I think, for like a wide variety of people. I think once you get into the web ground station part, it becomes much more application specific, and that's where we start running into these questions about does it mount multiple cameras, multiple vehicles, does it do log analysis and all this kind of stuff, and that's like a whole different can of worms. It's like a massive problem, and I think that one's really hard to it's much harder to move across applications.
Yes.
So I guess if I had any request, it's sort of when you're developing this, if you can try and keep those separated, so that we can use one part without the other part. You know,
Yeah,
assuming that's all open source, I think it is, right?
Yeah, that's our goal actually. The WebGCS will be one of those extensions we talked about, and on its separate container and everything, so you can just not use it.
Cool, great stuff. Really impressive.
Yeah, it's gonna be self-contained, so we can actually use different control software for rovers or ROVs, because I know rovers usually don't do video, so we'll probably need a map instead. We're also thinking about how to handle multiple networks for rover, for 4G, and maybe some satellite links for Mavelink only.
Yeah, cool.
All right. Any final questions? Well, thank you very much, William. That was absolutely fantastic. Looking forward to this being deployed widely and hopefully applied to other vehicle types as well. But
yeah, let's see if we get some
a really compelling system. And greatly appreciate your talk. So thank you very, very much.
Thank you.
All right. So so we've got a few minutes before we're scheduled to start the next talk. If we run against the schedule, then our next talk will be starting in about 15 minutes time. But now, do we want to take a break for a few minutes, or do we want to launch into the next session and then have some time for our sleeves for more time between, you know, after the next talk or the one after that? Any opinions?
I think a short break would be good.
Short break would be good. All right. Well, I have prepared a little slide so that the people on the live stream know that we're on a break. And so I will put that up, and there you go. Everyone see that? We're on a break. Check back soon. Excellent. Okay, so we'll have a few minute break and see everyone back. Feel free to sort of chat during this break, of course. The call's open, the live stream's still going. But otherwise, we'll be back in maybe 10 minutes time. And we'll start the next session. So if I just bring up the schedule here briefly, and there's the schedule. So the next talk is by myself, the systems update. And then after that, we've got Randy giving a boat update, and then Nick doing the ESP32 update. So see you all back here in 10 minutes or so. And of course, feel free to chat in the meantime.
There's a couple of new interesting words that picked up on that last presentation. One of them was a bracelet gimbal. I had actually never heard of that, but I guess it's a very small handheld gimbal.
Bracelet gimbal?
Didn't you say that? Didn't I hear you say bracelet gimbal? You were talking about how you're putting a gimbal inside the very small constraints of the inside of the ROV. What did you call that?
Yeah, I probably mentioned it was probably supposed to be brushless.
Oh, brushless. Okay, sorry. There is actually such a thing as a bracelet gimbal. It is a tiny gimbal that you attach onto your wrist, a bit like those handheld ones. But
oh, cool.
It's just nice to see these tiny gimbals appearing. And
you learned a new word accidentally.
Yeah, I guess it's not really a new word, unfortunately, but that sort of.
Yes, these gimbals keep getting smaller. I can't wait till a small gimbal camera is just like a secondary payload, and you can just attach a little tiny gimbal like you'd have on like a DJI or something, and it just goes with the aircraft. You don't even worry about it.
Yeah, exactly.
Yeah, that discussion.
Go ahead.
Oh, sorry. Go ahead.
No, I was just saying that, I probably shouldn't even say it, but, when I look at those, DJI Mavics and they've got that tiny little gimbal inside, I'm just envious, why can't I have one of those?
Yes, why can't we have them?
I think they cost, like $10 million to develop, so only DJI has done it.
Yeah.
Yeah, I guess they'll come eventually. Maybe, not initially in the form of a multi-copter gimbal, but maybe, as one of these tiny little handheld gimbals or something. And later on as a, specific drone.
Yeah, maybe more as we move more towards having, onboard companion computers, we will hopefully start having more high-speed interfaces available, so you can just start ripping camera modules off of other things, and then just figuring out how to get drivers for the actual modules. Yeah, like when you put a Raspberry Pi in, you can just talk over CSI directly to the camera.
Yeah, I think part of the issue is that they do the whole decoding in their own hardware in there. Encoding, by the way.
Oh, definitely. Yeah, I just think of how many cell phones do I have sitting in a drawer that have a camera far better than I've ever put on a drone, unless it's like a DSLR or something. Yeah, if I could take my old cell phone and take that camera and put it in something. So at least we know that there's all sorts of modules and stuff available, but there's so many hurdles to get it there. I think we're almost naturally progressing towards being able to do it though.
Yeah, I think so.
And that discussion on video encoding kind of opens up a whole can of worms. Yeah, between dozens of different encoding methods. The WebRTC method used for the Blue OS is very interesting. It definitely seems to be the best, most popular method and newest method that gives you low latency and a lot of redundancy, like error correction and so on. But it's it seems to be, it's really designed around operating in the browser, so you don't really see it in something like QGC yet.
Yeah, it's very annoying to work with, but it works pretty well when it works.
Yeah, then on personal projects, I've been messing a little bit with WebRTC just because I didn't think that I could get that onto onto an ArduCopter or ArduPilot vehicle yet. But there's all sorts of other video encoding methods that do have forward error correction, and they're starting to gain support. I know one of them with Dash. I'm trying to remember what the other one is, and I think those are interesting as well, because there should be the ability. I don't know if it was Dash or one of the other ones, but they should have the ability to do proper multicast streaming, which is a really nice benefit.
So Randy, I've been trying to get your attention in Skype, but I wanted to, if you could start recording, so we have two people recording all the time. Just in case my internet link drops out, we don't want to lose the recordings of the talks.
Presumably you'd still have the live streams.
Yeah, we should do, although I don't know how dependent it is on the computer that launched the live stream, which is my Windows box. Randy might be off on a break. Maybe he's not,
not listening. Sorry.
You are there?
You were talking to me. I just ran off to grab some more coffee.
No worries. I'm just going to ask that you start recording, please. We just always like to have two people recording in case I lose my link. Thanks, Randy. Excellent. That's great. Trying to make sure all the demos I'm going to give her are going to actually work. Always a problem giving live demos. How many people are on the call are thinking of coming to Canberra next year for the conference? Many people are willing to make the trek?
I was thinking about it.
You're thinking about it, given you live here?
Well, yeah,
I'll be there if I can.
I'm going to try.
Peter and I are definitely coming.
Awesome. And Seppo's going to be there. I'm just checking if he's listening.
Were you volunteering him?
Correct. And volunteering you as well, Buzz.
I've already said I'm coming.
Well, that makes that easy.
So is there a way of telling how many people we've got on the live stream? Don't have a lot of experience with live streaming.
Yeah, I think the Zoom interface actually tells you, at least they seem to have an interface element saying that, you know, there were so many people watching the live stream on it.
Right, okay.
30 people on the live stream right now.
Right, okay, great. All right.
Was it 27 in Zoom and 30 on YouTube?
So I think we can think about starting the next session. So, all right, well, the next talk is the systems update, which I've given each year we've had this conference. And so I'll just start that up now. So I don't think I need to give a speaker introduction. All right, so everyone see my screen there all right? Except I'm not actually screen sharing. That would be a no then. And maybe you can see my screen there now. How about that?
Yes, we've got it now.
Great. All right, so this is the systems update for 2022. And as usual, I sort of give a summary of what's been happening at the lower levels of ArduPilot. And there's certainly been a lot happening over the last year. So just a few little stats there at the beginning. 5,000, as of when I made this slide, 5,694 patches have been merged in the year up to the point where I made the slide just a couple of days ago. Over 3,300 PRs. So it's around a 10% increase over the previous year. So we tend to sort of be increasing year over year. About 350,000 lines of code have changed in ArduPilot in the last year. And we had 180 people contributing code in the last year, code and documentation, which is really a great, really great to see so many people contributing to the project. So firmware size has become more of an issue, and a lot of the discussions on our weekly or actually bi-weekly development calls now have been, whether we accept a feature in and the flash cost of the features. So you can see a picture on the top right there showing the state of the build server as of the time that I made this slide. and showing that we were really low on space with many of our builds down to the last few bytes. And so it has actually improved a little bit in the last couple of days. We merged a change here. So if I bring up the build list we've got at the moment, you can see that it's looking a little happier. And we've got just a couple that are low on flash space, but things are considerably happier. And this is just because in the last few days, we've merged a patch that built upon some work that Henry did to disable all but the u-blox driver on our really low flash boards. So the boards that were completely running out, the ones that were in this list down to their last few bytes, we've now disabled everything except the u-blox driver. The thing that's really allowed us to do that has been the introduction of the custom firmware server, custom.ardupilot.org. So this custom firmware server and really great work that was done by Will Piper for the GSOC project last year, and it's been very popular. So this is, if you haven't seen it before, I think most of the people on this call would have seen the custom build server. Basically, it allows you to go in and select a flight controller and pick the features that you want to include, and then do a build for that particular flight controller. So a bit more about that later in the talk. All right, so back where I was having my slides. Great. All right, so Shibios update. So we're still using Shibios 20.3. We'd just moved to 20.3 in my last system update. We're about due for the next major Shibios revision. And so we've already been doing some experiments with the 21.11 version of Shibios. And so the plan is that when we've sort of released the final version of 4.2.0, there will be a PR to update us to the 21.11. These are sort of year and month releases. So that's the November 21 release of Shibios. And so that's what we'll be targeting for the 4.3.x versions of ArduPilot. It's not a really major change, but there are a few key features that are important for parts of the project. One of them is improved Qspi support, which is really important as we've got new flight controllers coming out that come with Qspi Flash. And the main driver behind supporting Qspi Flash are really two things. One is some flight controllers rely on it. So there's the SP racing boards that Andy Pipe has been working on, which only have a 128K of flash, and then they have a Qspi flash chip with a lot more flash, hundreds of megabytes of flash space available. And that basically is seen as external flash that can be memory mapped into the address space on the flight controller. And to provide that, there are some issues with performance on that, but I think we'll be able to overcome those in the coming months. And it's going to be quite important as we keep adding features and we run out of flash space to have really good support for Qspi Flash. And I know that some other vendors are planning to incorporate Qspi Flash parts of 100 or 200 megabytes in future versions of their boards. So that's going to be quite important, the improved support for that. A big one is that asserts can be non-fatal. For those who are building their own firmware at the moment, one of the things that we recommend people doing whenever they're making significant system level updates is to do a build with the enable asserts option to configure. And when you do that, then Shibios checks a lot of the APIs. So if you, for example, you make a mistake with locking, or you use the wrong, Shibios class function from interrupt context or from thread context or whatever, there's a whole lot of checks for the validity of the Shibios low-level system calls. And what happens at the moment is when you violate one of those checks, that it will call a system halt, and you'd then be able to attach a debugger and get a backtrace. And that's great if you're doing bench testing, but less useful for a flying vehicle, because halting it will mean that the vehicle falls out of the sky if it's a flying vehicle, or perhaps floats off into the distance if it's a boat or a submarine. So what we'll be able to do in ShibiOS 21.11 is we'll be able to map these assertions to a non-fatal error, and we'll be able to map them onto our internal error system. And that will mean that they'll be logged in our onboard logs. They'll be able to be transmitted down to the ground station using Mavelink to say you've had an internal error, and we'll be able to examine those at our leisure without it causing a fatal exception. And I think that's going to be really important for catching these types of errors. We have had situations where an assertion has been failing for a considerable period of time in master before somebody does a build with for that particular type of configuration. For example, D-shot or a particular UART configuration before it's noticed. And so this will mean it will be possible for people on their normal development test vehicles that they're doing test flights on to be able to enable the assertions and map them into our internal error system, which should allow us to catch those exceptions a lot more quickly. It will cost us some flash space, so we're yet to decide whether we're going to make that in our default builds, but we certainly should at least make it available in the custom build server and in builds that individual developers do for their for flying on their own aircraft. And then we can decide at a later date whether we're going to enable these types of asserts with our general builds that our end users are going to get. Improved Ethernet support. So Ethernet is going to be, I think, an important part of the 4.3 development series. So we've already got some work being done by Tom and Sid on Ethernet support, and we've already got example flight controllers that have got Ethernet connectors. And so Ethernet's going to be, I think, more important, particularly in larger vehicles. So the improved support for Ethernet in the 21.11 release of ShibiOS is going to be very welcome. Finally, there's a completely new virtual timer implementation. And this was largely sparked by the discussions that we had with the ShibiOS core developers about some of the issues we had with lockups in the timers. And that's been an ongoing problem with the older release of ShibiOS that we've had. The 68 millisecond delays, for example, on the Maytech H743, and more recently where we had some watchdogs, which we spent a lot of time investigating. The core issue behind that is that the virtual timer implementation, which is the part of ShibiOS that schedules threads. So when a thread says, I want a delay for 3 milliseconds, for example, that it places that thread into a linked list of threads that are waiting on an event of some sort, on a completion of that wait, and the process of placing it into the queue relies on a certain piece of code running within a limited amount of time. And that's called the scheduling delta, which we've got set to a fairly conservative value of 10 microseconds in ArduPilot. The new implementation doesn't depend on that, which means that those types of problems where we had Flash causing very long delays and causing a watchdog should be completely a thing of the past with the new virtual timer. But so in the meantime, we've just had workarounds in our current version of ShibiOS. So quite recently, the latest beta of Plane and the upcoming beta of Copter, we've switched to disabling interrupts during Flash operations to make that time more predictable in the virtual timers. All right, so that's sort of it on what's happening with the core ShibiOS version. So I expect that in the next month or so that we'll have that PR and start switching to the 21.11 version of Shibios. Feel free to ask questions as we're going along, by the way. Okay, so some of the highlights of what's been happening in ArduPilot over the last year. And these are in no particular order and or no particular level of priority. And it's just some of the ones that I think are really the high points. There's been, as I said, 5,500 or more patches gone in. So there's been an awful lot of changes. But I think some have are worth mentioning as really key changes that have happened in the last year. The first is support for CAN-FD. And so that effort was led by Sid, and really nice piece of work. Hang on a second while I just sort out an audio problem here. All right, that should fix that up. Okay, so so really nice piece of work supporting CAN-FD. So this is part of the effort that moving to Dronecan. And so we're basically adding support for higher bitrate, what's called bitrate switching with CAN-FD. That'll mean that at the moment, all of our CAN packets are going at 1 megabit. And where we're using what's called BX-CAN or conventional CAN packets. With CAN-FD, the way it works is that the framing for the CAN packets remains at 1 megabit, but we're able to send the data at a higher bit rate. And the likely bit rates that we're going to allow for is 5 megabit and 8 megabit as the most common ones. But key to that is the some work that is upcoming that I think Sid will be explaining in more detail, which is to be able to negotiate what bit rates are available in across all of the peripherals and the flight controllers that are connected onto the CAN bus. So we've got a negotiation system that will make that possible. And I'm sorry, I've got another little audio problem here I just need to fix up. I kept getting an echo from my other computer. All right, that's gone now. Great. So hearing myself echoed with a couple of second delay was slightly annoying. Okay, so so CAN-FD has gone into master now. It's not in the 4.2 betas, but it is in master. So it is actually possible to configure now ArduPilot with CAN-FD, and you can select the bit rate. What hasn't gone in yet is the support for negotiating the bit rate between the different components. And that's really an important part of the support before we can really go live and start recommending that people start using CAN-FD. And so there'll be more about that in Sid's talk. Qspi Flash support, so that's the basic support for Qspi Flash has gone in, so we can support things like the SP Racer board. As I mentioned before, this is really important for expanding the amount of flash space, the amount of code that we'll be able to have in ArduPilot. And it is going to be an enormous expansion going up from typical flight controllers, either 1 or 2 megabytes of flash, up to hundreds of megabytes of flash available in some flight controllers. Parameters in Lua Scripts, I think, was a really nice step forward. That makes it much easier for users to configure Lua Scripts, and allows us Lua Scripts to move closer to being first-class citizens in the world of ArduPilot. Adding support for real applications and extensions of the ArduPilot capabilities from Lua. So being able to create custom parameters, both in terms of parameters that are completely new parameter spaces, new name, with completely new naming prefixes, and also extending existing parameter trees, which we've already got some examples of. So in the last year, we've introduced double precision navigation and estimation. That was a fairly major change which we applied to both EKF2 and EKF3. And this is part of an effort that I called Extreme ArduPilot to support really long range navigation. So we've demonstrated, at least in simulation, that ArduPilot is able to fly right around the world, so circumnavigate the Earth in an aircraft. So I did that in with a large fast aircraft in X-plane, and the EKF was able to remain stable over the entire flight. We did have a limitation of 1,000 kilometers previously with our EKFs, and although that was the hard limit, we actually had estimation errors start to come in at much shorter ranges, and our navigation code, the copter control code, for example, started getting oscillations at distances of the order of, a few hundred kilometers. So with the double precision estimation that we now support on suitable processors, so that's on the F765 and above, and the H7 processors, which many, if not most people are now running, we now can support essentially unlimited distances. We still do have a constraint if you're flying very close to the poles. So if you were trying to orbit, within hundreds of meters of the North or South Pole, then our estimation system will still have significant issues. And so that's something that requires another level of rework that has been discussed by Paul Rasber and myself, but hasn't been implemented yet. We have had people flying down in Antarctica and up in the Arctic area, but I don't think they're doing much auto navigation right near the poles, because the state estimation, at least using the EKFs, starts to get very unhappy if you're very, very close to the poles. Similarly, there's a little bit of a problem with our magnetometer support close to the magnetic poles. So the way we do our interpolation on our declination and inclination tables, that interpolation is too coarse-grained near to the magnetic poles. So if you were flying very close to magnetic poles and you were using a compass, you'd get significant issues. That can be solved by using the dual GPS moving baseline yaw, but it would be nice to have better support for flying with a compass close to the magnetic poles. It's just a matter of us changing the way we do the interpolation to better support that. Another major change was the ESP32 HAL. So we now have, it's the first time we've had a new HAL in quite a while, supporting the little ESP2 boards, which brings a really low cost solution. And there'll be more discussions of that later on with Nick's talk with Buzz. So many thanks to the enormous effort put in by Nick and Buzz to support the ESP32. It's been a really nice piece of work. We've had the switch over to Dronecan. So this is away from, it's partly just a renaming, but it also sets the scene for us doing some fairly major evolution of our CAN protocols. And that's really gone rather smoothly. Some of you may not have seen an announcement as well by the UAV CAN project. Pavel announced that they've also renamed. So UAV CAN now, the name UAV CAN is no longer associated with an ongoing project of any sort. So, so Dronecan is the successor to the original UAV CAN protocol, and what Pavel and the UAV CAN dev team was calling UAV CAN v1 is now called CYPHAL, C-Y-P-H-A-L, I think it is. The name UAV CAN still, of course, appears in a fair bit of documentation and on labels on devices and things, but over time, I hope that people will start using the name Dronecan. And we've also started some significant development within Dronecan. So particularly around the GUI tool, it's had a lot of enhancements in the last few months, and new messages coming in. And the new node capabilities to negotiate the capabilities of all of the devices on the bus. That's in prototype at the moment, being worked on by Sid and myself. And that's going to set the scene for us doing a fairly major evolution of the messages, bringing hopefully a lot more sanity to the message structure. Our custom build server that I've mentioned before, really big development. CAN over Mavelink. So this is part of the Dronecan project. We now support forwarding CAN, both CAN FD and the older BX CAN messages over Mavelink. And I'll be giving a demonstration of that later on in this talk, because I think it's a really useful diagnostic tool. Microsd formatting over Mavelink. This is something people have been asking for quite a while. If you've got a flight controller deeply embedded in a vehicle, then it's very useful to be able to format the microSD card in case it's corrupted or you just want to wipe it out and start again without having to pull it out of the vehicle and pop it into a separate laptop and format it. So we now support a command to format the SD card over Mavelink. That only works for SDMMC style SD cards at the moment. So they're the ones that are doing SD cards over SPI, which is used particularly on some of the F4 and F7 and smaller boards. We don't as yet support formatting those over Mavelink, though I would hope that we add that in the 4.3 timeframe. Finally, the log rate max parameters. I thought I'd mention those because I think there's a number of partners who might benefit from those. If you're doing very, very long flights, and some people are, like I saw recently, an ArduPilot quad plane, the electric quad plane doing a 6-hour flight, which is quite remarkable. And some people do even longer flights. Tom's been talking about flights that go for more than 24 hours. You've now got the ability to rate limit the log messages, and which is very, very useful. And you can separately rate limit the log messages going to your SD card and going out across your link to your companion computer. And that's really great for keeping the bandwidth that you're using up going to the companion computer down to a reasonable level, but also just constraining the how big your logs get when you've got really, really long flights. Something that I've been meaning to do is write an example Lua script that adjusts those rate max parameters based on the stage of flight you're in. For example, in a quad plane, you might like to have unlimited rate of your messages during the takeoff and landing and during the approach. But during the cruise portions of flight where you're doing a long auto mission, you might like to drop back the maximum rate limit. And it does support changing that dynamically. So it'd be quite possible to have a very simple Lua script that just looks at the stage of flight and adjusts those rates. And that would allow you to have the highly detailed logging during the really critical portions of the flight when, for example, during the takeoff and the landing. But during the long and hopefully boring parts of the flight, from the flight controller's point of view, reduce the rate that it's logging messages down considerably so that you don't get quite so enormous logs. And so I'll put together an example Lua script that does that hopefully sometime soon. All right, so there's sort of main system highlights over the last year, now I'll move on to a little bit on some of the CAN changes. So as I mentioned, so CAN FD support has been started, and more on that in Sid's talk. We've started on the Dronecan node capabilities message, which is the basis for us negotiating between all the devices on the bus as to what each of their capabilities are. So we use the minimum, we work out the minimum level that all of the different nodes on the bus support. So we make sure that when we move to a new message that replaces an old message, that all the devices that are consuming that message are happy. CAN translation is now possible in APPerif. This was a really interesting capability added by Tom. So it's now possible to have, for example, a G4 peripheral, which has 2 CAN ports, and to have one of those CAN ports talking Dronecan to the flight controller, and another port talking a completely different CAN protocol. It might be, for example, Piccolo CAN, or in the case of Tom, he had the MPPT CAN driver, the maximum power point tracker for solar cell management. And being able to do that translation really solves one of the core problems that CAN has, that you can only have one extended CAN protocol live on the bus at any one time. And so this allows you to use a translation node to translate from one extended CAN protocol to another. Now, something that I would like to add into 4.3 is, as I mentioned specifically, that you can only have one extended CAN protocol. You can, in theory, with a CAN bus, have one non-extended CAN protocol and one extended CAN protocol. So you could, for example, have a CAN LiDAR that uses a custom CAN, 11-bit addressing CAN protocol at the same time as having Dronecan on the same network. And so what I'd like to do is add a parameter for selecting one additional non-extended protocol to run in parallel with your main Dronecan protocol. And that would make things a lot easier. Cabling wise, you'd be able to connect up, for example, a CAN LiDAR or CAN radar and put it into the same CAN bus as your existing Dronecan network. And that would be a lot easier on the cabling to be able to mix the two on the same bus. And it's just a matter of registering that additional protocol and making sure that all the non-extended packets go to that protocol handler and all the extended packets go to the Dronecan packet handler. So we now have 3 different types of CAN servos that are available, which is really great. I've been wanting it for fixed wing for a long time to have CAN servos to be, get more adoption of those. So we have a new CAN servo from Hitech. I actually got one here on my desk somewhere that I was just sent recently. Now I can't see it under the pile. And we've got the CAN servos from Zeus and of course the Piccolo CAN servos from Karawong. So users now have a choice of CAN servos. And this is, getting us down towards the point of having all CAN actuators, so CAN ESCs and all CAN servos, which really give you a lot of advantages as far as having feedback available from all your actuators. So the next steps in CAN development, the complete the addition of node capabilities and for the negotiation of the capabilities of each of the nodes on the bus. We want to build much cleaner Dronecan DSDL backwards compatible with existing nodes using the node capabilities to maintain the backwards compatibility. That includes the CAN FD speed negotiation, and there'll be a lot more details of this and I think some demonstrations in Sid's presentation. All right, so Lua has had a lot of work done over the last year, and so it's really been rapidly maturing, and the scope of what people are using Lua for is really expanding very rapidly. So I wanted to point out some of the highlights that we've had in the last year in the world of Lua. I mentioned earlier the parameters in Lua Scripts, and I've got a little example of that down here in the bottom right corner. So this is from an example where we're extending the follow capabilities of a copter. So we've got an existing parameter tree, which is prefixed by FOLL_, and we can now add a new parameter table with that same prefix, and then we can add 2 new parameters. So we end up with FOLL orb radius and FOLL orb time. They're the orbit radius and orbit time, and that allows you to set up follow with orbiting around the target point rather than just in a fixed location about the target point. And it's an absolutely trivial Lua script to add support for orbit, and it's a great example of the way we can extend existing capabilities of ArduPilot with a Lua script without any changes at all in the C++ code. And being able to then add the parameters into the existing parameter space, I think is really powerful. We now support logging of Lua scripts for better diagnostics. I'm finding that really useful when people are using a Lua script and I'm not sure exactly what version of the Lua script they've got loaded. We now log the exact Lua script, the contents of the Lua script inside our onboard logs. And that's really powerful for being able to work out when there's a bug. For example, in the log, we might get there was an exception in a Lua script at a particular line number, but we don't know what that line number corresponds to based on the version of their script. And so now we've got the full Lua script that was being used during the flight available, and we can go and look at exactly what was being used and what needs to be fixed. So there's been some really nice work by Henry on expanding our applets. This time last year, we had just started the applets directory, and there was a single just sort of placeholder example applet. And now we've got a lot more applets. And so the ones that have had, the most development, the fixed wing aerobatic scripts from Henry is really quite amazing, the work he's done there, where he's able to have switch positions to do, for example, a loop or a rolling circle or a knife edge or inverted flight, etc., and being able to select those on switches. All of that was done using Lua Scripts and the scripting that Henry did, where it's one of the first examples where we've got multiple Lua Scripts cooperating with each other. So he's got a core Lua script that's handling the switching, and then he's got additional scripts that provide the functionality of each of those. And so we have a set of Lua scripts that get loaded, and those are collaborating with each other, which is a really nice thing to see. And so that's one of the most complex sets of scripts that we've got at the moment. Mission selection, where you can use a switch to switch between different missions. So you might have multiple missions and you want to be able to quickly switch between them. So there's a nice little mission selection applet. Smart audio control applets for controlling power levels on your video, your FPV video system. Forward flight motor shutdown for turning off different motors in forward flight, useful in quad planes where you only want to have a subset of your motors running in forward flight, and the on-VIF camera control, and that's for controlling the pan tilt zoom on-VIF cameras. So really nice to get those done as little applets with documentation. The key difference between an applet and example script in the Lua scripting for ArduPilot is that the applets come with documentation how to run them, whereas the example scripts just tend to have a few comments in the top of the file. And Henry has been our gatekeeper in ensuring that we get decent documentation on the applets and get them documented in the wiki. So thank you very much, Henry, for that work. I've mentioned the custom build server before, and it's certainly been a really, really useful addition, and it's basically been a key enabler for us to start moving some of the lesser used features of ArduPilot to not be built in by default, which is essential as we just keep running out of flash space. We're basically maxing out the available flash space on many of our boards, particularly the boards that only have 1 megabyte of flash. But we're down to under 200 kilobytes of flash left, even on some of our 2 megabyte boards. So it's going to become more and more important as we keep adding more features. We typically add about 5 to 10 kilobytes of flash space a week to ArduPilot of sort of new features. And so being able to move those off to only being, the lesser used features that are only enabled on the custom build server is really important. It also allows us to move the really rare sort of one-off flight controllers to be only built on the custom build server. So particularly for boards like this is a Nucleo board, so it's a prototyping board and not something you would generally fly with, although people have flown with that sort of board. I've seen pictures, and it's not necessarily a good idea, but it has happened. So those types of prototyping boards, we've shifted those across so that they don't get built in our standard builds. And instead, you can go to the custom build server and ask for a build for one of those boards. And you say, what type of vehicle you want and the board and all of the features you want, and it'll build you a firmware. So So it's been a very useful project, but there are some really key missing features we don't have at the moment, which we're hoping to fill those gaps this year, either as part of a GSOC project or just as general development. Really, really important, we need to support beta and stable branches so that people can do custom builds on our betas and stable releases. And that's going to become, more and more important as we move features out of being in our standard builds and move them only to be on the custom build server. So hopefully we'll get that in fairly soon. Support for developer feature branches, I think, is similarly very important, particularly when there's long-term development happening of a feature. And you want to get everyone in the community, your set of testers that you might gather together on discuss.ardupilot.org, and you want to be able to easily provide a build for any flight controller of that feature. So we really need to be able to, on the custom build server, select those developer feature branches and have a way to build those. Finally, we really need some better dependency checking. It's all too often that people find that they choose a set of features that don't go well together, and they end up with a failed build on the custom build server. So we really need to have better way of checking that you're enabling a sensible set of features. Or really, the important thing is if you enable a particular feature, that all of the other parts of the code that are dependencies of that feature get automatically enabled as well. All right, so most of the rest of my talk is on diagnostics and error handling, and I decided to focus on that in this talk because I think it's something that a lot of developers are not aware of, some of the features we've got for diagnosing errors, and that it's also very useful for partners who are trying to diagnose problems with their users' systems. So what I'm going to be doing is demonstrating how to use some of the key diagnostic systems that we have. And many of these diagnostic systems are new in 4.2. Some of them were available in a prototype form in 4.1, but most of them are completely new in the 4.2 releases. So I'll be talking about using the crash catcher system for handling catching hard faults, the way we log system files, how we log system storage, looking at stack usage, improvements to our internal error handling system, and finally I'll give a demonstration of CAN over Mavelink. So I'm going to start with a diagnostic example, and this is from a bug that we had that was fixed just a couple of weeks ago. And so what I'm going to do is stop the full screen here. And instead, what I'm going to show you is I've got a CubeOrange flight controller here, and this is running a version of the plain 4.2 firmware from just before this bug fix went in. And I wanted to show you how you can do some interesting diagnostics with this board. So what I'm going to do is connect to this board. So now connected into that board, and I'll just raise the font size a little bit here. So is that big enough for everyone to see what's happening there? Go a bit bigger?
Yeah, that's good.
That's good? Okay. All right. So now I'll just demonstrate this particular bug, and then I'll show how you can use some of our new diagnostic tools to diagnose the what's causing this bug and fix it. Now, this particular bug was one that if you set the airspeed type, it doesn't stick. So I'm going to go and change this airspeed type, and I'm just going to, pick a random number. I'm going to set it to say 5, right? And it really doesn't matter what I've set it to. And then I'm going to param fetch the airspeed type, and we can see that it is indeed set to 5. All right, so this is all quite normal so far. We've just set a parameter to a particular value. And what I'm going to do is I'm going to reboot the flight controller. Okay, and there it is rebooted. Great. And now I'm going to fetch that parameter again. And it's back to 0. Right, so this was one that I actually hit myself on one of my own quad planes, and very frustrating. When you set a parameter, it does set for that session, but then as soon as you reboot, the parameter disappears. And this type of bug can be very difficult and rather frustrating to track down. Now, if you can't find the bug immediately and you can't easily reproduce it, then what we would have done before is we would have, for example, attached a debug adapter to the board. And, if you've got the appropriate cabling and you've got the right sort of board that's got debug capabilities. But what I'm going to show you is a method where we can diagnose this without having to get debug on the board. And so the technique uses the fact that within our system storage, so if I show here, these are our sys files, which we introduced in last year in 4.1, the use of system files you can fetch via FTP, but we've greatly expanded the number of system files. And one of the system files we've added is storage.bin. Now, storage.bin is a complete copy of the system storage on the board. So in this particular case, on this Cube Orange, that's the FRAM chip, the 32 kilobyte FRAM chip. And that's why this file is 32 kilobytes long. On a board like, say, a Maytech H743, it would instead be, and I just need to somehow get rid of those silly notifications there. Well, I'll ignore those for now. Okay, so on something like a Maytech A743, it would be the 32 kilobytes of data that's represented in the flash sectors that particular board uses for its storage. But the reason this is important is the existence of this file, being able to download this virtual file from sys, that allows us to transfer the bug if the bug is related in any way to the to all the parameter sets. We can transfer that across to the computer and put it into CITL. So what I've done is I've downloaded that sysstorage.bin, and so there I have that file, that 32 kilobyte file now on my local system. Okay, and so that's a complete copy of what was in what is currently in the FRAM on this Cube Orange. All right, so what I'm going to do now is I'll just go make a nice big font there too, and I'm going to copy, see what directory I was in my conferences APM 22 directory. So I'm going to copy from conferences APM 2022, that storage.bin file, and I'm going to copy it over the file eprom.bin. So in CITL, we use a file called eprom.bin to emulate the storage on a flight controller, and it's the same size, 32 kilobytes. So I've just copied that file that I've downloaded from a real flight controller, and I've copied it over the eprom.bin file that I'm going to use in CITL. All right, which means that I'm going to be initializing CITL with exactly the same contents for all of the parameters, the rally points, the mission, the fence, etc. All of that data is going to be exactly replicated from the real flight controller into the simulator. Okay, so now what I'm going to do is Tools, Auto Test, Sim Vehicle, and I'm going to start up our normal simulator here. All right, so that will fire up the simulator. Wait for that to start up. Okay, so there we have the simulator running, right? And let's first of all check. So we've got a GDB session here. So we've got a debugger running. And the first thing I'm going to check is, have we replicated the bug? So we've now, does the bug actually transfer across? And the trick, of course, is you want to run exactly the same version of the code in CITL that was running on the flight controller where you had the bug. So what I'm going to do is start by param fetch airspeed type, and it's currently set to 0. Now I am going to go and set it in CITL, and I'm going to set it to, another value like 10. And check that it is set, and it is indeed set to 10. And now I'm going to reboot CITL. So it's now restarted, and I fetch it, and it's now 0. So we have now replicated the bug. We've successfully transferred the bug from a real flight controller into the simulator. And I'll be showing in a minute how you can transfer this from a user's log. You don't actually have to have the flight controller locally. You can actually get that storage.bin out of the logs from a user. All right, so we've now replicated the bug. So I thought I'd do the next step, which is to actually find the bug. All right, so what we're going to do is I'll just break in the debugger here, and I'm going to have a look at that variable, plane.airspeed. I'm sorry?
Can you make the debugger any bigger?
I'm not sure I can. It's already on huge. Sorry. I could, however, attach it in a different way. If it's really hard to read, what I'll do is I'll start it again, but I'll start it without the -G there, and then I'll attach it in another window instead. And that will allow me to have better control over the font. So that should be a bit clearer. So GDB -P PID of. All right, and okay, and all right. So that's actually, I'll just, yeah, unfortunately my terminal has stuffed up. And let me just reset that terminal and attach again. All right. Okay. So what I'm going to do is now P of plane.airspeed.param 0.type._value. Right now, that's I just happen to know where that variable is stored. Otherwise, you can look it up in the code. So that's the actual value of that airspeed type parameter. All right, and so I'm now going to add in a watch point on that variable. So that will show me when that parameter changes. Right, so when that variable changes, and so. Now what I'm going to do is I'll just, continue in there, and here's where I am running that, and I'm going to go and param set airspeed type, and I'll set that to say 11. Right, and in my debugger, it's now showing where we're setting it. So it's calling the set on the variable. So I'll just let that continue. And we can see the old value was 0 and the new value is now 11. So we'll just let that continue like that. And so now what we're going to do is we're going to restart the program and watch when that changes again. So I'm going to go there and I'm going to go R to rerun. Right, so R to run, starting it from the beginning. And it, first of all, it's going to show us each of the times that this value changes. So it's starting at 0 first from the initial 0 memory, and then it's changing to value 2. And if we look at the backtrace, we can see where it's changing it to 2. That's just the setup object defaults, because the default in CITL is 2. So that's not really interesting. Right, so let's continue and see when it next changes. And and when the restart with the attach, darn it, I have to do it with the -G because it's not restarting with the attachment. I'm sorry, you'll have to put up with the small font for me to demonstrate this one. So apologies about that, but I'll run through it fairly quickly, and then you can always squint at the video later. All right, so what I'm going to do is go and param set airspeed type to 12, and then I'm going to put a watch on plane.airspeed.param 0.type._value, so I can see all of the, and we can have a look at its current value. it's currently 12. And then I'm going to go and ask it to restart. And we see it first of all change into 2 with that default. And then we're going to see it changing to value 12, which is the value that we do want. So that's where, if we look at the backtrace, it's getting that value 12 from where it's doing load all. So that's our parameter load all where we're starting up. So far, so good. This has got the correct value at the moment. But let's now continue and see what happens. And there we see it changing from a value of 12 now to a value of 0. So this is the point where we're getting the value being reset. And if we look at the backtrace here, we can see exactly where that is happening. So if we go up to there, then we can see there's the code. So this is the line of code, and we can see that the issue is in our convert class code, which is doing the parameter conversion. And so that's the bug. And so there was a patch now to fix that so that it doesn't always do the parameter conversion. What it was doing was getting the value from the old 4.1 area before we converted the airspeed class. But the details of the actual bug itself isn't what I'm really wanting to show today. I just wanted to show the technique of transferring a problem from a real flight controller to a simulated flight controller into CITL. And that's a very powerful technique to be able to move across the entirety of the storage from a real flight controller into a simulated flight controller. All right, any questions about that?
Trich, I got a quick question. I don't fully understand why do you need to transfer the EEPROM from the flight controller onto the sim? Because the bug is in the firmware. So surely, take this example that you've just gone through, couldn't we have just run CITL to replicate the problem because we knew that there was a problem with that parameter set?
If we knew what the problem was, yes. But we didn't know that it was to do with the parameter conversion. We didn't know that the reason this bug existed was that this particular flight controller had been shifted from one aircraft to the other, and it used to be running the particular flight controller had gone through a history. Nobody noticed this for months, right? Because the flight controller had to go through a particular history. So the flight controller was originally installed on an aircraft with an airspeed sensor, and then it was moved to an aircraft without an airspeed sensor, which means the parameter was changed from being a non-zero value back to a 0 value. Now that wrote that 0 value into the EEPROM using the old parameter tree. And then it was moved to another aircraft where I then wanted to enable an airspeed sensor on that new aircraft, and I found that the parameter kept getting reset. But I didn't know what the bug was. I didn't know that it was because this wasn't happening on other aircraft. Other people found that they could set airspeed type all they liked, and it worked. And in fact, we've even got, we had auto tests, and we tested at the time. We added the class conversion code, etc. So it was the particular history that was embedded in what was stored in this particular storage.bin, the FRAM, right, is what we're trying to capture. And it's obvious now that we can see the bug, what the actual thing was, and it is because of that history. It wasn't obvious at the time that the bug actually occurred. And so this allowed me to basically move it across into an environment where I've got a much more powerful debug system, where I've got, watch points and a full, desktop debug system, a much easier environment to work with. Does that make sense?
That does, yeah. That's great. Thank you.
Yep. All right. Any more questions about that system of sort of moving things across from real flight controllers to simulator?
Yeah, I have a question. So it's transferring all the storage of whatever's in the flash or the FRAM on this particular board. So is that the same? Like, how does the simulator adapt to different boards? Are there any format differences between boards with different sizes of FRAM or anything?
So there are. So there are some boards. For example, if you were doing this from, say, a Kakut F4, which has a storage size of 15360, oddly enough, that's a particular number that works in with the way our flash storage system works on those boards. You would need to run CITL with that same layout, because of the way our storage manager works, we have a different layout of storage in different boards. Now, so it just so happens that, you know, our more sort of premium boards, the larger boards that are using FRAM, so like the CubeOrange and CUAV, X7 and Durandal and Pixhawks and all those boards, they all use this same 32 kilobyte size that CITL uses, which means it's very, very easy. But if you are on something like a Cocoon F4 or an Omnibus F4 Pro or similar, you would need to change one line in CITL to make CITL use that same storage size, 15360. And I can go off and show you where that line is if you like. But if you do need to do that, it is a one-line change in CITL to make those sizes match. There's also things about parameters. There's certain parameters that won't come across. There are parameters that don't exist in CITL that exist on real hardware. For example, there's a parameter that controls whether we do 3.3 volt to 5 volt level shifting on the outputs of pins, right? That's a very hardware specific parameter that's only on certain flight controllers and isn't in our simulator. Now, those parameters just won't be shown in CITL because of the way we do our keying of parameters in our storage. The keys are unique, even if it's on, as long as it's the same vehicle type, the keys are unique. So you don't end up getting collisions between the CITL parameters and the hardware parameters. So it actually does work really quite well. You will find, for example, all of your mission is transferred, your rally points are transferred, you know, your fence points are transferred. All of those things are transferred across. And all of your key parameters, your flight control parameters are transferred across. So it's not so much for actually going and then flying it in CITL, because you know your tuning and the mapping of your servos and things is likely to be different in CITL than it is on the real vehicle. It's really for this sort of low-level debugging where you're trying to find, you know, why particular behavior is misbehaving, and you want to replicate as closely as possible the environment of the real hardware within the simulation environment.
I feel like the answer to this question is no. Why would you ever do that? But can you upload the storage.bin?
Not at the moment. I have considered making it writable. We do make some of our system files and our sort of virtual file system files writable. For example, our mission file is writable. You can upload a mission using FTP as well as download, and as our geofence ones are uploadable and downloadable. So there's some, and same with our parameters. You can upload parameters with FTP as the parameter file and download. I haven't done it for the storage. We could. There would be some synchronization and locking issues that would make that tricky, but it would be something we could add if there's a need for it. And one thing that it could be used for is to clone a flight controller. So you want to take everything about all the storage on a flight controller, download it, then upload it to another one, and then reboot, and it will then be identical to the first one. That might be useful.
That's what I was thinking. Like, obviously, you can duplicate the parameters, but you could sort of make it.
That's right. There's more than just the parameters. You know, if you want, there are other storage areas you might want to replicate. And so, yes, it is something that we could add. We don't have it at the moment, but it's certainly something that wouldn't be particularly difficult to add. It would mostly just need to, when it starts the upload, it would have to lock it so you don't get erase conditions, and then upload it all, then wait for it to be flushed, and then you'd need to reboot to actually get for it to take effect. I don't think we'd want to update while flying, for example, your storage.bin. That could get, you know, some very nasty race conditions in that. You'd want to lock it down and then force require that the user reboot for it to take effect.
And I'm monopolizing the floor.
Please. Yeah.
You mentioned it's in the log, and is that also included if you're streaming the logs?
Yes, it is, and I'll be demonstrating that in just a second, the way you can get some of these things out of log files. Now, that is only in 4.2. In fact, this whole storage.bin is only a 4.2 feature. But yes, for 4.2, you can actually get the storage.bin off the flight logs that your users send you, or flight logs off your own vehicle. And that's very, very powerful. It means that if they report an issue, and if you suspect it's something to do with a corruption in their storage, a parameter corruption, history of it, parameter conversion, you want their exact mission, their exact rally points. For example, if they didn't, you want to get all of the rally points with exactly the format that it had and all of the details, then using their storage.bin and transferring into SITL is a very powerful way to do that, to make sure that there is really no difference at all, because it's an exact image of what was on that board. All right.
Yep. One question. Right, sure. You can use the storage.backs, like the string.backs, right, in previous firmwares to do the same sort of thing, but you have to detective hunt for the right
That's right. That's right. So there is on some, not on all boards, but on some boards, if you've got an SD card mounted, it will actually back up your FRAM onto the SD card at each boot, and we keep a cycle of those. That is another way to get this storage file. And you can use that similarly to transfer that into SITL. So that works with 4.1. It's just a new thing that we actually have it in flight logs and being able to download it live using the sys file system. All right, any more questions there before we move on? Okay, so I'll just pop back to my slides here. And what I've got next, the next demo is crashdump.bin. And now this is, so is it going, no, that's great, it doesn't go back to the start. So crashdump.bin, this is a fantastic piece of work by Sid. And so thank you, Sid, for the huge effort that he put into this. So crashdump.bin is storing the information needed by a debugger to get a full backtrace and inspect variables and look at the state of the autopilot, and make that information available via both the sys file system and in a log file. Now, where this is useful is if we've got a bug that is causing for example, a hard fault. Say, for example, we had a stuck overflow, or we had an error where we're dereferencing a null pointer, or we've got, similarly, all sorts of other bugs, all sorts of bugs that we could have in ArduPilot, particularly during the development phase. And when we get those sorts of bugs, being able to actually get a full backtrace and attach a debugger to the state of the vehicle is incredibly powerful. So what I'm going to do in this demo is I've got, in this case, I've picked on a CUAV X7 Pro. So I've got that, and I'm going to attach that to USB cable and show you what can be done with this. So people still seeing the screen okay? Let's attach there.
Yep, looks good to me.
Good, okay. Always got to get some audio feedback, make sure that I haven't, for example, lost network link and I'm just talking to myself. Okay, so what we've got here is I've just connected to this CUAV X7 Pro, and what I'm going to do is use one of the abilities in Mavproxy to deliberately trigger a bug. Right, so we're going to trigger a hard fault on this board. Now, I could have just picked, a previous bug that we've fixed, but it's also quite nice to be able to test this capability. So we've got this command in Mavproxy called hard fault autopilot. Okay, now if you run that, it says invalid hard fault command. And that's because we don't want to, through tab completion, accidentally run this sort of thing within flight, because these commands are active whether you're flying or not. So you've got to give it a string at the end there, which needs to say, I really mean it. And you really, really want to trigger a hard fault on this board, right? So that you don't accidentally, type that in when you're flying your vehicle and regret, that tab completion. So I'm going to trigger that hard fault on this board. And what it's going to do is cause this board to watchdog and reboot. All right, so this is the dreaded watchdog, and it should come back. There it is, booting up again, and there's our watchdog. Now, this is not an all zeros watchdog. This is a hard fault, so it's got all of these hard fault registers. Now, in the past, in 4.1 and 4.0, we just had to try to read the tea leaves from these registers, right? And that's really all we had. And we would then try to work out, the cause of this hard fault just in those registers. And that was really difficult, very, very difficult task. So what I'm going to show you now is what Sid has developed to allow us to get a lot more information. So if I do ftp list at sys, then what you'll notice is that this file crashdump.bin no longer has 0 size, right? It normally is a 0 size virtual file. And this is recorded inside our hard fault handler, and it's an image of the stack and memory at the time of our main threads at the time of the hard fault. And it's done in a format that can be accepted by the GDB debugger. All right, so what I'm going to do is download that. Now, that file actually does persist. So you can see one of the things we've often said in the past, don't reboot. We want to have a look at the board and see what's happened. We can actually reboot this. So I'll go and reboot the board, and you don't lose that. It'll no longer be saying watchdog, right? Because the watchdog messages only come up on the ground station at the time when it's booting directly from a watchdog. So we're no longer getting those watchdog messages, but this crashdump.bin has persisted, and it's actually stored in Flash. What it uses, it takes advantage of the fact that we haven't filled Flash on this board yet, right? We've got some spare space in the top of Flash, and it saves the crash dump into that spare space. Now that means it's lost if you flash a new firmware, because when you flash a firmware, it erases all of Flash, right? But as long as you don't flash a new firmware, this file is still there. So what I'm going to do is, so I'm going to download it, list at sys, and I'm going to ftp get at sys/crashdump.bin, and I'm going to download it as cd1.bin. And the reason I'm calling it CD1 is I'm going to have a CD2 in a minute, where I'm going to show you how to get this same file from a flight log. All right, so we're going to get it first of all. So we've now written this file, which is a 206 kilobyte file, cd1.bin, and fetched in just, a fraction of a second. Okay, so we've now got that log file, and so there's our cd1.bin. Great. So what do we do with that file? Okay, so now we want to find out what was happening in the flight controller at the time that hard fault happened. All right, so what I need to do is, first of all, switch across to the branch that this was running. Now, this was actually running the Copter 4.2 branch. All right, so, and I'm going to back up in conferences APM 2022. I've got this cd1.bin, and just for simplicity, I'll just copy that to the current directory to make the command lines a little bit easier. So cd1.bin is sitting there. So what we do is we run this little script, tools debug gdb crash dump, right? Which is a little helper script that makes it possible to use these crash dumps. And if you just run it, it gives you a little bit of help. And you need to give it the ELF file, which in this case is going to be the ArduCopter file, and then the crash dump itself. So that's build CUAV X7 bin ArduCopter. That's the ELF file, and cd1.bin is our crash dump file. So what this script is going to do is attach the GDB debugger ARM9 EABI GDB to this ELF binary with this crash dump file. for its memory image. All right, so there we are, and it's now processing that. And we're now in there. So we can now do things like info threads, what threads we're running. All right, these were all the threads that were running at the time and what state they were in. There it all is. Now I can actually get a backtrace, and there's a backtrace showing exactly what was happening at the time of the crash, at the time that it had the hard fault. And we can see in this particular case, we were calling the update receive function to receive a Mavelink packet. Then we handle the handle command long, because the force a crash hard fault is a command long in ArduPilot. And then there's the handle pre-flight reboot function, which is the one that actually handles that particular packet, because it's a pre-flight reboot packet with some magic parameters that triggers the hard fault. So we now know that the hard fault happened in that set of code. And so that's much, much nicer to work with than working with just those raw register values, and it allows us to really see what was going on when that fault happened. So very, very powerful. Now, in this particular case, this firmware, this build firmware is a production beta firmware. It's not it's one of our beta firmwares. It's not built with debug. So when I do this backtrace, if I go up, it doesn't show me all the local variables on the stack and that sort of thing, because I didn't build with debug symbols. But even without the debug symbols, I can get the names of the functions. But if this firmware had been built with full debug, then I would in fact get a whole lot. I could inspect all the variables and have a look inside the data structures and that sort of thing. So it's a very, very powerful technique for transferring from a crash dump from a bug that we've got in ArduPilot and attaching a debugger to that on the after the flight, after the problem has happened. So any questions about that? No? Okay. Well, related to this is the next one is how you get these types of things out of a log file. All right. So I'm going to go back to where I was on this board. So this is again the same CUAV X7 board that I had before. But what I'm going to do now is I'm going to load that just so I've got GPS lock, which makes processing logs faster for an odd quirk of Mav Explorer. So what I'm going to do is I'm going to arm this vehicle, and every time we arm the vehicle, we save a certain set of files to the onboard log. And that includes the crash dump and the storage.bin and a bunch of other useful files. So I'll just show you how to do that. So it's just ordinary arming of the vehicle. So the users had an issue, and then they rearm. They go for another flight, and or just arm it on the bench. So I arm it, and when I arm it, it then, as per usual, it writes a log file. But this log file is going to have a copy of the crash dump in the log file. All right, and you'll actually see a little message that'll pop up. You'll see it says logging sys crash dump.bin. For the crash dump.bin especially, we actually pop a message on the console so you know that it is actually logging a crash dump. The idea is to give the operator to know that this log file that they're actually contains a crash dump from a previous problem. All right, so we've now got, I'm going to disarm again. And so it's now disarmed. That's just an alias, disarm force. And so let's log list. And we see log number 132, log download 132. And we'll see the little progress thing up here in MavProxy, which shows the percentage. We are through downloading the log, 40%. Nearly there, 60%. 80, 90, and And there you go. We've now finished downloading that log. All right, so we've now got log 132.bin. Right, so there's our log file. Now I'm going to load that log in MavExplorer. Okay, so in MavExplorer, we have a new command called the file command, right? So if I run file, then what it's doing is it lists all of the files in the log. And this is something that I was discussing earlier with Michael about adding support for this in Mission Planner. I think it'd be very nice to be able to extract these files. So basically our onboard log file, the bin files you have on the SD card, or they would also be on the companion computer if you were doing log streaming to your companion computer, contains a lot of the key data that you would normally get live. So if you're a company that supports your users and your user has an issue and they send you a flight log, you should look in it and see whether there's information in these files that can help you diagnose their issue. So for example, we could see whether they were running out of memory, right? We could go file sysmemory.txt. This is a copy of the @sys/memory.txt from when they armed. And we can see all the different memory regions on this particular board. So it's an H7, which means it's got 6 different memory regions, right? Not just a single memory region like on the old, most of our older boards, or 2 on something like in a 427. So it's got these 6 memory regions, and we can see how much is free on each memory region, what is the largest one we could allocate on each region, and these type flags say whether the memory region is DMA capable or fast memory, these sort of flags. So this gives us all that information about what was going on with their memory at the time they armed. All right, we can go and grab, for example, their UARTs. Now, this gives us detailed information about what was happening with their UARTs at the time they armed. You can see, for example, which UARTs are active. We can see that I was on USB, and so I had lots of transmission going on serial 0, which is a USB port, and lots of receiving going on those as well. So you can see that that's highly active, but these ports, for example, you can see that I wasn't using UART serial 4, serial 5, serial 6. It gives you both the serial number and the UART number. The little stars tell you whether it was using DMA. So we can see that this particular one, serial 1, has DMA available for receive, but not for transmit. And this one has DMA available for both transmit and receive. Really useful when diagnosing speed issues, packet loss, talking to companion computers. You can go and look at the time you armed whether you had DMA available on each of these channels. Let's have a look at our timers. All right, so we have information about the timers we're using and what frequency they're running at and what mode they're running in. We can see that we've got DShot 600 running on that particular timer. We can see the clock that was coming into it. This is the sort of information, for example, if Andy was helping you debug a DShot issue, you could give him the timers file and he would then immediately know exactly how he's setting up all the clocking, etc., for that DShot. Really, really useful information. All right, what are some of the other ones I want to look at? Are the threads? Yes, so let's have a look at the threads. Okay, so this shows all the different threads running in ArduPilot. The ArduPilot is very much a multi-threaded flight controller. And we can see the main thread, what its priority was, the address of where its stack was, which is useful when you're diagnosing with a backtrace. How much stack total it had and how much stack was available. That's the stack free and the total stack available to that thread. So you can see whether any of the threads had a low amount of stack, was running low. And you can also see what the priority was of all the various threads. We can see, for example, that this had a special ADIS 1647, which is for that fancy IMU, and it's running at a very high priority. And there's no particular stack issues that are showing up in these particular ones. All right, so we can see that scripting was running. Okay, so we can, of course, download our storage file. So I can go file that and let's call it e.bin. So I can go and download the storage file out of the log file. So that example I gave a minute ago where you wanted to transfer the storage into a simulator or potentially into another flight controller, if we made that writable, you can download that out of a log file, which is very, very powerful. So you can get that from your users and then try to reproduce, get exactly the same mission, the same rally points, etc. Absolutely identical storage as to what you had on the real vehicle, even though you don't have direct access to the real vehicle. We can, of course, get the crash dump. So I can go and download the crashdump.bin and have that as cd2.bin. So now we've downloaded that crash dump file, which has the same one. So I can now, let's go and copy that CD2 into here, and then I will be able to go and get a backtrace from this crash dump that came out of a log file this time instead of downloaded with FTP. And there it is. So we can now get a backtrace from a log file that a user has sent us, which is very, very powerful as far as, you know, finding the cause of an issue. All right, now you also got all your Lua scripts. So we can go and have, I've got a ship landing Lua script on this particular one. I can have a look at that Lua script just by going file in the name of the Lua script. And there's the exact Lua script that I had running on the vehicle at the time it armed. And so I can tell exactly if I get a bug in a Lua script, I can go and look at the line number. You can also specify the name of file to download into rather than just displaying on a terminal. So if you go like that, then it downloads the Lua script as a file locally rather than just displaying it on a terminal. The default is if you don't specify the second file name that it just displays it on the terminal. All right, so you get the idea. We've got our storage memory. You do actually get the full HWDEF in case they've modified that. So you can have a look at exactly what they had. It has the comments removed, but you have the complete HWDEF for the boards. You know exactly what they were running, which is, again, very, very powerful if you're not exactly sure what was running or they're using the custom build server, for example. This would show all of the modifications they'd made in the custom build server, which would show up as lines of extra defines at the end of the hwdef.dat. All right, any questions about that at all?
What about missions and rally points?
The storage.bin has that. So you can get that out of the storage.bin and then start up CITL. We could separately dump those, but it's not really necessary because you've got the whole storage bin. That just makes things a little bit simpler. But yes, we could separate that out and have, you know, mission.txt, etc. But it would just add flash space as a feature, and it doesn't. I actually find it more useful to take that storage.bin, copy it to EEPROM, just fire up CITL, and then you can, you know, view the waypoints in whatever ground station you feel like, rather than just having them in a particular text format, because the text formats don't necessarily bit for bit replicate exactly what was on the system, whereas it does bit for bit replicate it by using the storage.bin. All right, any other questions at all?
I was just thinking about automating this, or, you know, building this into scripting tools. Is there a way to extract the files using Mavlog dump or something else that's not interactive like this?
Yes, I think, have I already done that? Let's see, Mav files. I thought I added a Mav file decode. I've got a Mav FTP decode. I could certainly make that available as a separate Python script. I didn't think it was too bad firing up Mav Explorer, but but yes, we could have this as a Mavelink tool. It's a very simple piece of code. If I bring up mavproxy and command file, so the code to extract it, this is the complete set of code for extracting all of the files from a log. It's just a few lines of Python. It's terribly simple because we made the file format very, very simple. So we could easily extract that out as a separate little script, which, for example, extracts all of the files out and just shoves them into the current directory or maybe into a subdirectory. And then, so yes, it is a very, very simple thing to do because it's a extremely simple file format that's used. The only complexity in here is handling duplicates. Occasionally, if you armed twice, for example, you actually get every file twice. And so it's going through and handling those ones. And it's also reporting on gaps, because if you've somehow lost a message and you've got a gap, it tells you you've had a gap in that particular file. So any more questions about the files in logs?
I guess we don't have this ability in Mission Planner, right? I know
not yet,
Planner.
Although I wouldn't be surprised if Michael is typing the code as we speak.
Nice.
We did discuss it this morning on the sort of the pre-call discussions, and it would be, I think, pretty easy to add in Mission Planner. So Michael, have you thought about this?
Michael?
Not sure Michael's online at the moment or has microphone on, but
there's a button in Mission Planner, to extract a whole bunch of other things, missions and parameters, et cetera. It goes through, parses it, pulls out those bits, and makes them available in separate files. And it would be nice if those were,
that's right. We do have Mav Explorer for Windows, of course, so you can fire it up. I'm sorry, was that Michael?
Into it.
He's looking into it. Yeah. It's something we could potentially do it as a plugin as well to Mission Planner. I've been meaning to learn how to write plugins for Mission Planner. I haven't yet written my first plugin, but I think it would be quite a nice little plugin to do that.
And sorry, I know I've asked this question before, but it is possible to stop the Lua scripts from being included in the log file, right?
I think we might have added an option for that. We certainly discussed that at the time because
because one of the nice things, obviously not for me personally. Everything I do is open, but some people want to have their Lua scripts remain private, and of course you could just use your log, and that would be fine. But if you wanted to,
but there it is there. So it is in there. So the SCR debug ops, if you set bit 2, which is value 4. So if you set SCR debug to 4, it would suppress the logging of the Lua scripts. It shouldn't really be saying data flash, it should be saying to log file. But yes, it stops the logging of that. Yes, we should probably make sure we test that and just make sure before we release the final 4.2. But the intention was to be able to have a way to turn that off, to default it on, because I think most people would want it on, but have a way to turn it off in case it's important.
What if arming fails? That's often more the type of logs I get sent. Do you still get all this stuff on a failed arming?
At the moment, it won't log all these things with a log disarmed, which is the other obvious way to do it, just to set log disarmed to 1 and then get the log. At the moment, it doesn't. That's something that I've listed as a bug in my 4.2 bugs lists for plain, and that I was intending to discuss with Peter the way we could fix that. It's just the way it hooks at the moment. It hooks into the arming step. Because what you can do is just do a forced arm, and you can force arm the vehicle. You could even have the safety on when you force arm it, and so it doesn't actually spin anything. But yes, that is a lack at the moment.
Arm a real vehicle.
We could also have a Mavelink command to do this, to trigger it, or to force this to happen. But of course, if you can also just download it using the FTP interface in Mission Planner and download all of these files directly yourself, because Mission Planner already got a nice FTP interface.
Yeah, I guess you could have a Mavelink. I'm about to try to arm Mavelink command, something like that, or a start logging Mavelink command.
Yeah, I think we could have a Mavelink commands, to open log and write all these things out right now, please, sort of thing. We could.
If I'm thinking right, then if you have a failed arming, then we should in fact log these things, because you've gone through the arming step, and we have a little hook thingy in there where we'll log for 15 seconds or something on a failed arming. But I can certainly see why setting log disarm to zero wouldn't
Yeah, it doesn't work. It's just a matter of knowing how we fix that. What is the best way to fix that? And whether it should log them again. If you do have log disarm, should it log it again when you arm? I think it probably should, because you really, the data at the time you arm is more useful than the data at boot, because all your DMA and UARTs and things and what's being used is more useful because your system's only just started.
Yep.
So I think we should probably double log it. Yeah. Okay. All right. So so that's probably enough on those files in logs. So continuing down our diagnostics demos, stack logging. Okay. So I've got this same little log file. Oops. Log file here and log132.bin, and this one's a nice simple feature. We can just do, we've got, if you tab, you see all the things you can graph in Mav Explorer. One of them is this stack log message, and the simplest way to get it is just the dump stack, and that will dump all of the stack messages. And so there they are, and I'll just make it a bit wider so it's a bit easier to read. That's probably better. And so what we can see now is it cycles. It cycles every 1/10 of a second. It writes out one stack message, and then it cycles around between all the different tasks. And you can see here that it's logging actually task number 255 there. That's the interrupt stack. And so that's the critical one. If you run out of interrupt stack, that's bad. You will end up getting a very, very nasty fault. So you've got to make sure they're stack free. So for each of the tasks here, we have the total amount of stack available for that task and how much is free, plus the name of the task. The ISR is the interrupt service handler. So here's our main ArduCopter process in this case. So it's got 7168 bytes of stack, and we've got 4.4K free. Our idle task, we've got 144 bytes free, and this UART receive. So we have a thread per UART on the transmit side. So this UART2, that's our transmit thread for each of these UARTs, and then we've got a single thread for all the receive of all the different UARTs, and we can see how much free space there is. So this is useful just if you think that they might be getting issues with running out of stack in a thread. For example, if they ArduPilot, if you get below 64 bytes of stack available in a thread, it will report an internal error of stack overflow. Now, it isn't actually overflowed yet, it's just getting close to it, but it reports it as a stack overflow error. So if you get one of those stack overflow errors, the problem is you don't really know which thread it is that's had the problem, and you don't know what triggered it to use all that stack. So these stack messages in your log file are what give you that extra information. So that allows you to see the history of the stack. You can see, earlier on in the flight, what happened to the amount of stack used on each one. You can then work out, at what stage of the flight, at what you were doing, mission upload or starting auto or whatever, at what stage of the flight the stack for that particular thread became low. And it also makes it very, very easy to see which threads are running low on stack. So this is what we reach for when we do little patches that might adjust up or down the amount of stack space that a particular thread has. This stack logging gives us the information that allows us to know, to know whether that's needed. So any questions about that at all? All right, so we'll move on. And so this next one, I'm going to need help from the audience. So Josh, are you available to provide assistance?
It should be already streaming.
Excellent. All right.
Been streaming for an hour.
Great. So what this is going to demonstrate is CAN over Mavelink. And this is, we've had, and I'm also demonstrating forwarding of Mavelink. So Josh has Mission Planner attached to a flight controller. It's a Cube Orange, I think. Josh, is that right?
Yep, one cube
Cube.
orange.
Yep, and he's got 2 CAN buses enabled on that cube orange, and he's got some devices on one CAN bus and other devices on the other CAN bus. And what he's done is he's used this little nice interface here. So I'll just go full screen here. There's this, under the advanced setup, you've got this Mavelink mirror button. And that Mavelink mirror button walks you through the process of mirroring all the Mavelink that's coming into Mission Planner across to another address on the internet. Now, I deliberately have a public IP address on my home server, and that allows me to have a fixed address that is used. But you can use dynamic addresses as well, as long as you know what the address is. So he's set it up to forward to my address. So he's coming from the East Coast of the United States, forwarding Mavelink from that cube orange to my computer here. Okay, so what I'm going to do then is I should have, it's a little bit hard for me to see because the way, no, okay, I've just start up again. I'll make sure I don't have any Mav proxies running in the background, and I'm going to, so if he's forwarding it to 15.550, I use 15.550 usually rather than the default to 14.550. That's just because I'm often using 14.550 internally in my network. So I make 15.550 be what comes in remotely from other users. And I'm going to, what I'm going to do is start up Mav proxy, and it's going to accept Mavelink in on 15.5 UDP 15.550, and then it's going to show me the console, and then it's going to forward it out back to my own computer. And you will understand why in just a second. So here I am, and I am now connected to Josh's cube orange over there in on the east coast of the US. And I can show his parameters, etc. So I've downloaded all of his parameters, and let's have a look at all his CAN parameters. And you can see that he's got both CAN ports enabled, and he's running the Dronecan protocol on both of those devices. All right, so that's all well and good. This has been available for ages, being able to do CAN forwarding, and I could now forward that on to Mission Planner, or I could have received it directly in Mission Planner. So this is a very, very useful way of being able to diagnose errors with users' computers and help them with their setup. So I often connect in this way, and then I share screen with them, and when I'm adjusting parameters, I'm explaining what I'm doing. We're going to go one step further. I'm going to start up the Dronecan GUI tool. All right, so I'm starting that up, and you notice that I had forwarded Mavelink out from this Mav proxy out to 127.0.0.1.14.550. So I'm going to connect the Dronecan GUI tool to Mavcan 14.550. And what that's going to do is have the Dronecan GUI tool receiving CAN packets over Mavelink. And so I'll start that up. And now I'll enable the local node ID. And so there we have it. We are now seeing all of the CAN devices. We're managing the CAN devices on a Cube Orange on the East Coast of the United States from Australia. And so I can go and have a look at his airspeed sensor, for example, and I can fetch all his parameters, right, and check that he's got the right parameters on his airspeed sensor. It's a little slow, you can see. You know, I can make it faster by clicking this low bandwidth button. Now, what that does is, I'll actually show you what that does if I run up the bus monitor. So here I'm going to have a look at all of the packets. This is now getting every CAN packet that's going on in his CAN bus being relayed to me here in Australia. So I can see all of his packets and exactly what's happening. You'll notice there's only about 16 packets per second, right, happening here. It's sort of 16 to 8. And this number up here, the third number is the frames per second, CAN frames per second. I'm going to undo the low bandwidth tick box, which is up here. Right, so I'm now going high bandwidth. Now I'm getting hundreds of packets per second being forwarded over the internet. So this only works when you've got a decent, internet link. Not really fast. It's only tens of kilobytes to, 100 kilobytes a second sort of level. It's not massive amount of bandwidth. But I'll just pause that now and show exactly what we've got. For example, here's his raw airspeed data. So we can see exactly what is happening on his CAN airspeed sensor. I can see the magnetic field state because he's got a compass on this bus, right? And I can see a GPS. So he hasn't got a GPS fix. He's probably indoors. And so it's showing, the exact state of what's happening with his GPS. So we can basically look in a great deal of detail what is happening on his CAN bus remotely. So the way this is useful is you're on the phone to your user. You ask them to forward Mavelink to you. You fire up the Dronecan GUI tool, and you can walk through issues that are happening on the CAN bus remotely. And the low bandwidth button is there to cope with, you notice when I press low bandwidth, what happens with low bandwidth is at the ArduPilot side, in other words, inside that cube orange, it's setting a flag to say to only forward messages related to parameters and status and firmware update and a couple of other ancillary messages, right? So just the messages needed to be able to look at the parameters of a node and to be able to get the node status and uptime and that sort of thing. And that reduces the bandwidth requirements enormously. In fact, I've successfully used this with an old slow, SIK radio. Things like this sort of radio, you can actually get diagnostics on your CAN devices in flight over a really low bandwidth radio like that if you use that low bandwidth option. All right, so next thing that's very powerful about this is I can change which bus I'm looking at. Now, those of you who use the GUI tool with the 4.1 version will know that you have to set a parameter to map it onto a USB port. And the parameter says which CAN bus you're mapping. And if you want to change which CAN bus you're mapping, you've got to change the parameter and then reboot. With this CAN over Mavelink, you just change the bus number here. And what you'll find is the set of devices. We can see we've got, there's a here GPS on the bus, and we can now attach that here GPS and pull its parameters. So there's the here GPS control, see exactly what's set on that device. And we can then change back to the first bus, and it immediately takes effect. We've now got all of the devices in our first bus. So we can change between buses instantly to see exactly what's happening on both of their CAN buses remotely. Now, sure, some of you are wondering, can you update firmwares? And indeed you can. So it takes a few minutes, but I updated the firmware on Josh's Maytech airspeed sensor remotely from Australia yesterday. So I could do it again now if people are interested in watching it, but it does take a few minutes. It's slower than a usual update. And it only works if you've got a recent bootloader on the device, because the original CAN bootloader we wrote for AP-PRIF has quite a short timeout for the round trip time for talking to the client that's sending it a firmware. And so it constantly times out when you're on the other side of the planet, just because of the speed of light and network delays, etc. But the latest version of the bootloader has a longer timeout in it, and it works quite well. It flashes, for the yesterday when I was checking with Josh, it was flashing at about 2 kilobytes a second. So a 200 kilobyte file would take about 100 seconds, which is a bit longer than it would normally take locally, but still quite acceptable. If you're flashing it over a low bandwidth link like a radio like that, it can be done. I have updated firmwares over a radio like this onto a CAN device. You can even do it in flight. You could actually update the firmware on each of your CAN devices in flight if you wanted to. Anyone who's got an octa-quad copter could be the first one to land with different firmware version on each of their ESCs than they took off by upgrading one at a time in flight, relying on the failover. That would be possible. But I'm not sure whether anyone's ever going to actually try that, but it'd be an interesting possibility. So you can actually update firmware over this, and particularly useful if you do the low bandwidth, so it stops all of the other messages coming through. So just the firmware update is using your bandwidth rather than consuming it with all of the sensor data. All right, so any questions about that at all? Nope. Okay. So when we're talking about the cloud stuff later, one of the things I'd really like to see is with some of the cloud control, that particularly what the talk from Hefny later about his cloud control stuff, being able to forward Mavelink in that cloud control system, so that when you're controlling a fleet of aircraft via a cloud-based system, you'll be able to forward Mavelink to devices like this and actually inspect CAN buses and update and change firmwares remotely. On via these cloud control systems, and I think that'd be something be really nice to have for a future version. Okay, so that's enough about the CAN forwarding, and so let's go back to the slides.
Oh, Tridge.
Yep, Tom.
That's Tom Pittenger. There's always a thing on that GUI tool that I've always wanted to use, but never could quite figure it out. Since you had it up there, I thought I'd ask you.
Sure.
The filter option, like if I want to look at just one ID or one packet on.
Yeah. Yeah. Okay. So why don't we have a look at? I'll go full bandwidth, full rather than low bandwidth, and we'll bring up the bus monitor from Josh's one. All right. And say, for example, I'm only interested in the fix2. Then I can just go fix2 like that. It takes a substring of the packet, and now I'm only seeing the fix2 packets here. Is that what you meant?
Yes. Okay. Can you do it by just by device, maybe? Is that
the source ID? Or I haven't tried doing it by source ID.
Yes.
So that's something that's probably is quite useful to be able to say a particular device. I just use it in the simplest possible way, which is put in a substring. I didn't write this feature.
You can add another filter, an additional filter, and just type 125.
Right. Okay.
I forget how
I think it's that button. You don't say source 125 or something like that?
No, it doesn't work like that.
Yeah. All right.
Wherever the additional filter button is, you do that.
Yeah, all right. So this might be for a future tutorial rather than sort of exploring it at the moment. But I just do it with that simple way off. And you can also, of course, graph. And you can, for those who haven't seen it, there's been a few other features added. You've got control in your ESC panel now for sending the safety off and sending arming things so for testing ESCs. And of course, we've got the plotter. So I could, for example, for those who haven't seen it before, I'll go and do a plot of, for example, the number of satellites that that you're getting over there, which is probably not very many. So sats used, and I can pick a color for that plot. And so this will now do a little graph, and it's fairly boring, I'm afraid. You need more satellites over there. So you can now, plot field. So we could plot, it's probably more useful to be able to plot something like your magnetic field. So if I do, let's see, what about equipment, magnetic field strength, and magnetic field in Gauss. And so this has now got the 3 values of your magnetic field. So it's a vector. And so if you rotate that device over there now, Josh, then we will.
Yeah. I am, so it should be.
Yep, it is moving about. So this is now plotting the raw values coming in on the bus, on CAN bus. And so again, this is quite useful when you're doing diagnostics. You can see exactly what's happening on the bus. So this is coming all the way from east coast of the US to here, looking at magnetic field strengths.
I found the subscriber being the most useful for driver development.
Right. Okay. All right. So good stuff. I will move on from that now. So let's go back to the slides. And so this is now a little bit about what I would like to see at sort of at the system level for 4.3. As people should have already heard, we've gone to a new 6-month release cycle. And so 4.3.0 should be in beta in July of this year. And 4.3.0 final should be out around October of this year. So we've got a, that's our new 6-month cycle from what we've, we used to be a roughly 12-month cycle, and so we're now half that, and we're trying to get releases out a bit more quickly. So these are my top features that I would like to see at the system level. CanFD, with all the node capability stuff, definitely. So that's, I think, really important to start getting that rolled out. The new Qspi release that I've mentioned, the better Qspi support. Some Ethernet work. Tom and Sid have already started work on support for Ethernet. I'd really like to see Ethernet to be a supported feature for 4.3 if we can. I'd really like to be able to update firmwares from Microsd. And this is particularly important. We have a large fleet of vehicles. Imagine you've got a drone light show with 1,000 vehicles, and you might like to update the firmware on all 1,000 vehicles. Going around with a USB cable to each of them is really painful. So being able to upload the new firmware to the SD card using MavFTP, and then getting it when the next reboots, you send a reboot command and it sees the file on the SD card and flashes the firmware. I think that would be very powerful. It would also be extremely useful on vehicles where the flight controller is deeply embedded in the vehicle and the USB isn't readily available. I think it would be very, very useful to be able to update the firmware via off the microSD card. And it's something that I've started prototyping.
If you need any more motivation for that, I try to update the firmware from the companion computer, but on some vehicles you can't reboot without powering down the companion computer. So being able to update from the card would be huge for those too.
Yeah, I think it'll be a very useful capability. It's only going to be possible on boards that have got enough flash space in the bootloader. So you're not going to be able to do this, for example, on a Q Black because it's a 16K bootloader sector and that's full. We've only got a few bytes free. But on, for example, an H7 base board or an F7 base boards, I think it'll work. It'll be very easy. We can just make it a standard feature. So I'd expect that future releases, I'm hoping that in 4.3, this will be a standard feature to be able to update your firmware from the SD card. Multi-session FTP, as we make more and more use of the Mavelink FTP protocol, at the moment, there's only one FTP session that can happen at a time. So if you've got multiple ground stations or the ground station trying to do a mission and a parameter and a sys file all at once, then it just doesn't work. What happens was when you open a new session, it cancels the old one. And the protocol itself supports multi-session. It's just our server-side implementation inside ArduPilot doesn't at the moment. It kills off the old session when you start a new one. So we need to fix that and support that multi-session to be able to take better advantage of the Mavelink FTP. I'm thinking of adding, we've got an independent watchdog at the moment, what's called the IWDG, which is where we catch really bad things going on in the flight controller. I'm thinking of adding a windowed watchdog as well. The advantage of the windowed watchdog, which is another type of watchdog hardware built into all of the STM32s, is the windowed watchdog would allow us to have a fault handler for when our main watchdog is just about to fire. And that would allow us to, for example, to log that crash dump for an arbitrary watchdog, even all zeros watchdogs, timer lockups, those types of things, the ones where we don't currently get a fault, which means we don't get the crash dump. If we had a windowed watchdog in there that gave us an interrupt when we're just about to get the watchdog, then that interrupt could do the dumping of all of the information. And so that's something that I'm hoping to get in for 4.3. I think we should consider removing or disabling EFK2 for 4.3, just because the flash space savings, and whether we just disable it, whether we have it in the code but not built by default. We already have it disabled by default at the moment. We've done that, since 4.1. The EKF3 has been our default state estimator. But I think to save the flash space, we should consider whether we're going to not have it built in on most of our flight controllers, or maybe all. And so if you really wanted EKF2, you would have to enable it in the custom build server, or we could go as far as just removing it completely, which would mean we'd save us the maintenance burden. So we'd like to hear feedback from partners that might still be running EKF2 and why you're running EKF2. Is there some compelling reason for keeping it around? And if nobody can provide a good reason for us to keep it around, then we'll probably remove it and save the flash space for other features instead. So any comments on that before this opportunity to stand up for EKF2 and why it might be important?
I'll just admit that we're still using it, but for no reason except inertia.
Right, okay.
So if we're feeling really good that EK3 works as well and better, then
yeah, we're very confident EK3 at this stage, so I think we should consider removing it. So that'll probably be a dev call topic in the coming weeks. All right, finally, Henry asked me to remind everyone to keep the development docs up to date and the user docs up to date, and that link there takes you to the latest issues of things that need to be documented, and a lot of them have got my name against them. This is just a reminder that, our documentation is really important for the good user experience. And so this is why I've got all the developers on the call. Yeah, Henry?
Actually, that's the wrong issues list.
Oh, no, wrong one. Darn it, I thought I got this right.
4.2 is the one that needs work. This is the stuff that's already been released.
Okay, that's this one.
And this is all the stuff that is undocumented. It's not documented, nobody will be able to use it. And
right, okay. So, all right, we've got, at least it's a lower proportion that is against my name, but still quite a few. Yes, there's a fair bit more documentation we need to get in there.
And again, I'm more than willing to work on any of it, but I need some bullets to explain it to me
to get started.
On that. So,
all right, okay. Thanks, Henry. All right, so that is it as far as my systems update talk. Sorry it droned on for so long, but I hope that was useful. So, any final questions before we move on?
Tridge, there's a question you might want to answer in the chat.
Okay, let me see if I can.
From the Zoom chat.
Okay, there you go. All right, that's in the chat. How does the EKF outsource params handle EKF3? All right, so that's really a Randy question, as you did that work. Randy, do you want to answer that?
Yeah, so there's 3 banks now. In EKF3, it's better than EKF2. In EKF2, you could really just have one sensor. With EKF3, you can actually switch between the sensors in flight. So there's a wiki page. I think it's called something like GPS, non-GPS transitions, and it goes through the parameters. But in any case, the short answer is EK3 source pause Z. So EK3 source 1 pause Z is how you would change the main sensor used for the altitude estimation.
That's this parameter there that says which sensor it's going to use for the Z position. So that's the vertical position for the first bank of available sensors. All right. So, any other questions?
How do you get those strings to define what the parameters are? That's fancy.
The new version of Mavproxy does that. It has you have to do param download once, or when you want to update. So if you do a param download, it downloads that, and so when you go param show, then it actually labels all of them to show what it's set to. You can also do param help. Param help EK3 source 1, pos Z, and that explains what the different values are. But yes, it's it now displays as a comment whenever you set or show parameters, what the current setting is. It also decodes bit masks. So if I do param set, I don't know, arming check to 7, then when I show that, that's showing it as all parameter and compass. So it decodes both bit masks and values when you're displaying them in Mavproxy.
Fancy. Thank you.
No worries. All right, any more questions?
I feel like that download needs to happen once automatically at some point.
Yeah, the problem is that often people use Mavproxy in an embedded environment, a companion computer. It may not have internet, and it could clag things up. So that's why I didn't. But yes, Mavproxy is full of these little sort of hidden gems like that, and you learn them by coming along to talks like this. But yes, it might be, we could perhaps display a warning, if it hasn't have it, or if it's really out of date, suggestion, download your parameters. Or the other obvious one would be to add it into the menu here, parameter download docs or something like that. That would be very easy to do, to add that into that menu. That might make it a little more discoverable. I expect a patch from you shortly, Tom.
Sure thing.
Why
Excellent.
is it not just in the Mavproxy distribution? There's too many configurations, or?
We could bundle it potentially. Yeah, that would be possible to bundle that in. We'd have to download it at the time we build Mavproxy, download the latest docs, and then embed them in as a default set. That would be something we could do. Yeah. All right. So we're running low on questions, so we might move on. So I'll stop sharing, and so now let's have a look at our schedule and what we're up to. And
the schedule has Randy next.
Has Randy next. Okay. Now, what was the timing on that schedule?
I think he was supposed to start 45 minutes ago.
Well, no. So Randy is supposed to start at. Oh, really? Did I go for? How long did I go for?
Yeah, I'm afraid so.
Oh my God. Oh wow. I way. Sorry, I completely listened. My apologies. Okay.
Sorry.
Well, Randy, shall we have a break of a few minutes, or should we jump straight into Randy's talk? Sorry, I thought I was actually running short, but not long. So, all right. Randy, do you want to jump straight in, or do you want to have a break first?
Whatever. What do people feel like? Do people want a couple minutes?
I'm good to go. I don't know about the rest of them.
I'm good to go.
All right.
All right. So,
then.
Okay, over to you, Randy.
All right. Okay, so let me share my screen here. Okay. All right, so I'm going to give a little update on boats. As per usual, all comments, feedback is welcome at any time. Don't hold back. So the first one is just a little reminder of some videos. There's some videos that have appeared over the last year. So just remind people of some of the great vehicles people are building. So this is two videos. One of them was the, these are both from RC Test Flight. Let me just go back a bit, again, try again. Remember this one, the Banana Slug, which is a little hand-built boat, does a really long distance mission. It's over 20 kilometers, I believe. And then the next one that you might remember is RT Test Flight's solar boat. This is moving quickly, which again is very inspirational. This is another example from Andrew R.W., who put a lot of effort into these autonomous buoys. And you'll see there's a long discussion on the in the forums where he details how he built them, etc. This is the boogie board boat from Chris Dalke, I believe. And this frame is amazing. So many people have built boogie board boats. It's incredibly popular. Next video is another autonomous buoy. This one from David Bullinger. Uses it for his local sailing club. And yet another autonomous buoy, this time from Roberto Navoni from LaserNav, who's been with the team for a long time. The important thing in this video is not the boat sailing around, it's the quite large red inflatable and autonomous buoy that he's using. This is John Easton's mapping boat. This is his new version called the Amy 2. And it's gas powered. And it's part of his business actually of providing detailed maps to fishermen. This was another famous video from Mike Holden. This is his autonomous sailboat sailing around the very large sail drone, autonomous drone boat. So only one of these boats has ArduPilot in it. This is the somewhat famous Razor and CleanBot autonomous boat for cleaning up garbage in a harbor. Oops, sorry about that. See if we can get back to where we were. Skip forward here a little bit somehow. You just get to see them all again. Sorry, I'm not sure how to. I guess we get to see them all again. Maybe multiple times.
Try right arrow.
Oh, there we go. Nope, nope. Oh man, how many times can you see this video? So one more time, Andrew W's buoy boats, Chris Delkay's boogie board boat, David Bullinger's autonomous buoys, Roberto Navoni's autonomous buoys. A lot of autonomous buoys. I actually left out some autonomous buoy videos, if you can believe it. Yeah, so now John Easton's gas-powered mapping boat. Mike Holden's autonomous sailboat. The Razor ClearBot trash collecting boat. And last but not least is my mapping boat. This was made in conjunction with a company called Lighthouse and also Shimano University. And that's it. So it's just one extra video at the end. Okay, so yeah, I just wanted to give it next a little bit of background on boats and why they're important and why there's so much interest in boats. So you know, one of the things is that a bit like flying drones, boats allow you to go where you can't, allow people to go where they can't easily go themselves. Also, you know, we spend all our time on land, but as everybody knows, you know, 70% of the earth is water, and it's mostly empty, which actually makes it easy for us because unlike, you know, rovers, which tend to be rolling around in close proximity to, you know, people and objects, you know, boats don't have to worry so much about that. The object avoidance is not such a big problem. You know, compared to copters, the vehicle's weight doesn't matter much. It's got the water holding it up. So you can go very long distances. You know, my mapping boat, for example, can do 70 kilometers, you know, even with, and it could go further if I just put more batteries in it. One interesting thing about the range, though, is that it can do very long range at low speeds because at low speeds, the efficiency is really high. But the range and the power consumption just drops off a cliff as you get to higher speeds. It's not at all linear. So for example, my mapping boat can do 70 kilometers at 1.5 meters per second. But if you try to go 3 meters per second, double the speed, and it goes slightly less than 20 kilometers. I think, the next 2 points are just about sort of the market opportunities. There are, of course, lots of autonomous boats out there, but they're generally closed source and very expensive. It's a bit like the early days of drones, where you could have a quadcopter that would cost $80,000. Autonomous boats, you can have a 2-meter boat, and they can very easily cost $70,000 or $80,000. So there's a lot of opportunity for ArduPilot-based boats, which can be much less expensive because, of course, you don't have to pay for the software development. Also next is just the manned boats are huge business. We think about fishing and shipping, etc. There's a lot of opportunities there for autonomous boats to replace some of those manned boats. And some possible applications, ways that we see people using ArduPilot drone boats and other boats. There's, of course, amusement and entertainment. So those autonomous buoys are definitely finding a real place out there. Of course, there's racing as well. There's photography, videography. The next big application is mapping. So like John Easton has a whole business set up around mapping, and there are lots of other businesses out there who do mapping as a job, as a business. And the reason is that amazingly, only 21% of the seafloors has been mapped. You can have a look at that link to CBIT 2030, which talks about it. But there's vast areas of the sea that haven't been mapped. And next one is delivery. We don't see too many autonomous boats being used for delivery yet, but we have had a couple of inquiries from like India and maybe Indonesia. So there's opportunities there. Next is surveillance and monitoring. So, there's a lot of, not exactly conflict, but there's always, issues around, fishing rights and who's allowed to fish here or go there, et cetera. So, drone boats could be used for surveillance and monitoring to make sure that everybody follows the rules. Next one is something that I'm involved in, which is environmental monitoring and cleanup. So I work with some universities, and my drone boat is useful for this. So, for example, one of the great things about drone boats is that, unlike manned boats, it's very easy for them to go to exactly the same place, taking exactly the same route many times. So that's very good for environmental monitoring, because you can go back to the same place and collect data in exactly the same way, and then you can compare it over time to see if the environment is changing or not. One of the last point is just around the opportunities to combine drone boats with submarines. So submarines are fantastic in lots of ways, but they have this big issue in that they can't normally use a regular GPS. And so there are underwater GPSs which are available. So I've seen multiple projects being proposed where some of these underwater GPSs are connected to drone boats or manned boats, and then the submarine can figure out where it is in relation to those drone boats. So that's another opportunity which is definitely out there. Any questions, comments? Okay, moving right along. So this is just about some of the recent progress, or the progress of the last year, I guess, for boats. So in the drivers area, we've added and improved the BL Heli and D-Shot support. So that's mostly Andy Piper. We've added solar panel controllers. This is Tom Pittenger. And I've put this on my boat, although it's not in the most recent video. We've added support for the torpedo motors. And the important thing about this is that it allows the boats to travel much more quickly. So previously, most of our users were using DC trolling motors or gas motors, gas engines, I guess. But we've added support for the torpedo motors now, which are electric and provide tons of feedback but also they allow the boat to travel at more like 3.5 meters per second. Peter Hall added AIS support. So this is the boat equivalent of ADSB. So you can see where manned boats are. A bit like ADSB though, the number of boats that actually have AIS transmitters attached is quite limited. But I was lucky enough recently to do a big mapping mission out in Shimane in northern Japan, and a couple of large ferries floated by, and I was able to capture them and see where they were with the AIS support that we've added. Next is the Extreme ArduPilot project, which Tridge mentions in his slides. So this allows boats to go really long distances. So I'm really looking forward to the day when somebody has an ArduPilot powered boat, traveling across the Pacific or the Atlantic or some other large body of water. Small thing, we've added this misdone behavior. So this means that when the boat finishes mission, it can switch into loiter mode. Previously, it was just always hold mode, and then it would drift away. Small thing, but important. We've added support for Lua Scripts to be executed within missions using the nav script time mission command. So that's great for adding custom behavior to your missions. Next is in the navigation area, we've added S-curves in position controller navigation to replace the old L1 controller. And I'll talk about this in more detail in the next couple of slides. We've improved the vectored thrust support. So vectored thrust is, of course, when you have like an electric motor and it's being aimed by a servo. We've improved that support so that it more accurately gives you the thrust and turn rate that you want. And we've done a bunch of bug fixes. So Peter Hall did a fix recently to sailboats loiter feature. So when it handles heading into the wind properly. Also, we fixed up a bunch of small bugs in how we were handling motors hitting their limits. So make sure now that that we don't get high turn buildup in the speed controller, which could lead to bad behavior during missions in particular. And Peter Hall also did a fix recently, I think, to the Omni boat support. So Omni boats, I'm sure everybody knows, but Omni boats have not just not one motor, not two motors, but 3 or 4 motors. So it handles one of the motors hitting its limits slightly better. Any questions? No? Okay, moving on. So perhaps the biggest change that's gone in, and it's gone in quite recently, is the adoption of S-curves in Rover. And this took many months to get done, but hopefully it's worth it. Now, this is not included in 4.2, and I think that was definitely the right choice. It's sitting in master, and it's going to sit there, getting more testing until 4.3 goes out. Anyway, it's quite a big change. So I just wanted to try and familiarize everybody with how it works. So previously, the Rover software is a descendant of the plane software. So it has been using the L1 controller, and that was working okay. But the L1 controller has, at least as it was implemented in Rover, had some limitations. So perhaps the two big limitations are, well, the first one is that it would only ever look at a single segment at a time. It did not do any forward planning. So, if the boat was traveling between, along this segment here, it would only look at the origin and the destination. It would not look at the next destination. So this meant that, as the vehicle, basically normally, the vehicle would reach the destination, it would then forget about the previous segment, and it would immediately move on to the next segment. The vehicle would overshoot the corner, which is okay for some applications, good for some applications, not good for other applications. But in any case, it would overshoot the destination, and then it would get a massive, lateral acceleration request coming out of the L1 controller to get it back onto the path. So that was That was one limitation of the L1. The other issue is that the L1 controller is really just a lateral acceleration controller. It just tries to get to the vehicle. It just tries to provide a lateral acceleration to get the vehicle back onto the path. It does not try to provide a speed. So it just uses the current speed. So basically, the L1 controller and the speed controller were very separate, and that meant that we had to add in all kinds of little band-aids here and there to make the two of them work well together. So, for example, as the vehicle approached the destination, it would slow down. And then another one was we used to have the lane-based speed control. So if the vehicle, for some reason, ended up drifting too far off the path, it would just slow down the desired speed in the hopes that that would give the L1 controller a chance to get the vehicle back onto the line. So we had those kind of band-aids in place, and those are all gone now. Now we just have S-curves in the position controller. So is that okay? Yeah.
You had mentioned, Randy. Yeah, this is Tom Pittenger question on. You mentioned that it uses the L1, which came from Plane. Is there any talk of moving S-curves to Plane?
Well, that's of course up to Tridge and the other Plane developers, maybe you as well. I was thinking that there are some problems. Is Leonard here? I'm sure Leonard will be here. I also had this in mind because planes and rovers are perhaps closer than copters and planes. So I thought the rover implementation might be a good test run to see if it was appropriate for planes. I think there will be some problems. S-curves have this assumption, at least at the moment, that when you hit your maximum acceleration, like you can configure the maximum acceleration that the S-curve path will reach. And if it looks like it's going to go over that, then it will reduce the speed. And but it will reduce that speed right down to zero, which is obviously not something that planes can physically do. So I think it's a good test case, but I'm sure that S-curves would need to be modified for plane.
I think this is Bill Geyer. I think if we were able to implement airspeed into copter for the navigation, that would be a good test case, because obviously airspeed is a big player for airplanes, and so I think that would be a good test case for how well it would work with planes.
Cool.
And of course, trying to keep the constant speed so that it doesn't go below stall speed or some sort of minimum speed.
Yeah.
If we were going to add it, I think probably we'd make it optional, at least in the beginning, and mostly because it isn't really something that people have been asking for, whereas there were significant navigation problems that rover users were really hitting, that I think which drove you towards put this effort in. And we're not really seeing that on fixed wings for the way people are using fixed wings. And so it would be quite nice to have it as an option and see how people found it. We have had done in the past. The original fixed wing controller was a vector field controller, and then we switched to the L1. We actually had both of them in for a couple of releases, and then we had a parameter to switch which one you want to use. So we'd probably do something like that, and then see how it goes in rover, and then maybe have it as an option, and then see how well it works.
Yeah. Okay. Any other questions, comments? All right. So okay, I'll go into now the details of how we've implemented S-curves and the position controller. So there really are two parts to it, two sort of separate parts to it. The S-curves are there to calculate the path. So we pass in now obviously the origin, the destination, and the next destination to the S-curves. It actually comes up with two separate S-curves, and then we blend them together. But that's all kind of hidden away. So what you get out of S-curves is a position, a velocity, and acceleration at any point in time, along this path. So these are sort of the ideal position, velocity, and acceleration. You get those at every moment. And so on every iteration, we update the S-curve's time. There's an S-curve time in there. And then it sort of advances, and produces these targets. S-curves, of course, is 3D. In Rover, we always just have the vertical part set as 0. So really, it ends up being 2D. Then we take those, for example, the desired position, which is this green dot on the line here. And we pass, we actually pass all 3 of these into the position controller in a single call. And then within the position controller, it looks at the vehicle's current position, compares it to the target position, and it passes that into a simple 2-dimensional P controller to come up with a sort of a velocity. We call it a target velocity. So now we've got, this position correction based target velocity. So then we come up over here to the top right here. So what we've got is 2 velocities now. We've got the S-curve desired velocity. This is the one that came out of the original S-curve path. We've got this velocity target, which is to correct for the position error. We add those 2 together to come up with a total velocity target. And then what we do is we pass this into the position controllers. Well, the position controller passes that through this velocity to acceleration 2-dimensional FF plus PID controller, right? And so obviously it compares the target velocity to the actual velocity, and that error is calculated and then turned into a velocity correction acceleration target, shown in purple here. And then we do something very similar again. We take the S-curve provided desired acceleration, that's what we call it, desired acceleration, and then the velocity correction target acceleration. So just as a small point of naming, we call the things coming out of the S-curves desired and the sort of corrections as targets, right? Okay, so now we've got our total velocity and our total acceleration. One thing I forgot to mention actually was that this total velocity target is limited. So we don't allow it to become higher than the WP speed. So say you've got it set to 4 meters per second, it'll never be longer than 4. And also we pass it into simple avoidance as well. Simple avoidance, we have different types of avoidance in Rover and Copter. Simple avoidance is the one that just tries to stop the vehicle before it hits things. So this is not the path planning. It's not bendy ruler or Dijkstra's, which try to get you around an obstacle. This is just the simpler, lower level, simple avoidance, which tries to stop the vehicle before it hits things. So we pass the velocity into that as well. And that might also shorten or even reverse the velocity target. Okay, so, right. So now we've got these, this target, this total velocity and this total acceleration, and we have to get it into the attitude controller somehow. So the attitude controller in Rover there are basically 2 low-level controllers. There's the forward back speed controller, and then there's the turn rate controller. So for the forward back speed controller, we take just the body frame forward back component of the total velocity target. So you can imagine, you can see this orange vector here is sort of pointing, mostly up. The vehicle is pointing slightly more to the right. So, just most of this velocity target would end up getting passed into the, speed controller, but not all of it. A little bit that points back towards the line doesn't get passed in. Well, the part that is, perpendicular to the vehicle's heading does not get passed into the speed controller. Then for the turn rate controller, we take the body frame lateral component of the total acceleration target and we pass that in. But that is, of course, an acceleration. That's a lateral acceleration. That's not a turn rate. So we convert that lateral acceleration into a turn rate using the desired forward speed. So the forward back component of the speed. So that's what goes into the lower level controllers. And that's about it. There's a couple of other little things we had to do. So for example, to stop the vehicle from getting stuck, we make sure that this desired forward speed never drops too low. Yeah, that you know, you can see a little calculation here, but you know, you just want to make sure that the vehicle doesn't stop, because, you know, at least on some vehicles, like the Ackerman steering vehicles, you can't turn unless you're also moving forward. So there's kind of a minimum speed that we apply to make sure the vehicle doesn't stop and therefore can't turn. Yeah. And that's about it. Any questions?
Hey, Randy, Bill Geyer.
Hey.
So how, this is on boat as well, right? This would be boat.
Yeah.
Is that correct? So how well does this handle the fact that, you know, obviously it has airspeed and currents, and that sometimes the boat's nose may not be in the direction that it's going to be traveling? Does the S curves handle that correctly? Like, so it can crab effectively?
It does. Yeah, Tridge brought this up as well as a concern when I first started on the you know, the S-curve project. It's totally fine. So that really is handled. It's handled just as well as it was previously. So you've got a desired velocity here. That is not, you know, if we're trying to, you know, move back onto the path, you know, we have a desired velocity going to the left. That doesn't necessarily mean that we point the vehicle's nose to the left. That's not, no, it will crab just like it does now, or like it does in 4.2.
And so, I mean, but for copter, that's not the case. For copter, it actually, your nose is always pointed in the direction you're traveling, at least from what I think.
No, not really. I mean, where's Leonard?
Well, I mean, I guess if you had like a region of interest that you pointed it at, I guess it doesn't have to be. So I guess it doesn't have to be, because
it leans the vehicle, right? It leans.
Yeah.
It will lean in the direction that it wants to go in, but still, you've got this velocity layer here, which I think takes care of it. So, you know, if you're trying to move, you know, to the left, you know, say for example, this vehicle is trying to move back onto the line and it's not moving back onto the line for some reason, you end up getting, you know, I-term buildup. Well, you get a P error, and then, you know, as it drifts away from the line, you get a P error, and then you get, you know, maybe I-term buildup if you've got an I-term or an I-gain set. So, you know, the desired velocity will, the desired acceleration will increase, you know, in that direction. And so the vehicle will turn harder and harder and harder, right? This, you know, this turn rate, it'll turn harder and harder back towards the line as it drifts away. Does that make sense?
Yes, thank you.
Any other questions or comments? Okay. Next is just some little overview on the logging. So some of the logging has not changed. Let me first just say that this is a log from Eames, my main sponsor, and they I think were the very first people to test this on a boat. They tested it yesterday on a boogie board boat, and went okay. A couple of little problems that are written down here, but anyway, I thought it was a good opportunity to share what the logs look like, because I had to look at this log. Some parts are not changed. So for example, we still have the end tune messages are still there, and they provide you, you know, the desired yaw, the actual yaw, and the cross-track error. So that's the same. And then the steering and throttle, you know, the logging from the lower level controllers, that's also still there, unchanged. No, nothing to worry about there. What's new though is we have this PIDE and PIDN. So this is the velocity controller, the output from this velocity controller. Well, inputs and outputs from that velocity controller are here. Split into the north-south frame and, well, east-west frame. And then, exactly like Copter, we've got these position controller north and position controller east logs. And if you look closely, you'll see there's a TPN and a PN. So that is the target position coming out of the S-curves, and then the actual position. That's what's stored there. Then we've got DVN, which is desired velocity north, and target velocity north And then we've got a velocity north. So again, the desired velocity north, that's from the S-curve. The TVN is the S-curves plus the position correction. The velocity that comes from the position correction. And then finally, we've got the actual velocity. And then we've got the same thing as well for the acceleration. So the desired, target, and actual. And in this log, we can see, the vehicle was coming from the right here and then went north. Did a pretty good job of staying right on the line towards waypoint 2. Then it was actually set up to do a pivot turn though. So instead of doing a nice S-curve turn like we would have hoped for, cutting the corner, it floated, it reached 2, it tried to stop. The pivot turn controller took over. And while it was turning, the vehicle drifted with the current. And then it started on its way towards waypoint 3. And you can see here that it did not try hard enough to get back onto the path. Now, since then, they've actually done another test where they turned off the pivot controller, and it was beautiful. It was wonderful. The vehicle, cut the corner nicely, stayed right on the path. So I think, that's one possible change that we'll make, is just to maybe turn off pivot turns for boats. I don't know. Still thinking about it. And here we go. Any questions on that? Hopefully that helps people analyze S-curve logs on rover. Okay, things that we still need to do. So the position controller, I think actually S-curves are going to be fine. The issues, if we hit any, I think are all going to be in the position controller part. So Leonard wrote the S-curves, I wrote the position controller parts. Of course, the problems are going to come from the position controller. One issue is that the position controller is working in the northeast frame, which is just like Copter. I sort of wonder if maybe we should split it, change it so that it works in body frame instead. And that might allow you to have different gains for, lateral versus forward back. We've had a few testers, of course, mostly using rovers. And so we've got gains which we think work for all those testers, but I think it's still a bit up in the air as to whether our default gains are the best for everybody. Clearly from this log, it looks like we need an iTerm. By default, we don't have an iTerm. There's also inevitably probably going to be a couple of bugs introduced. I tested it for a long time. We had a lot of beta testing as well, but we have had some reports that bend ruler is not working quite right. So we'll need to resolve those over the coming months. Okay. If there's no questions, then I'll move on. So the next slide is just about the ongoing or the forward-looking plans for boat. I think we've made a huge amount of progress on rover and boat. Thanks to the help of all the other devs as well over the last couple of years. And I think we've got the navigation and control parts working really well. There are I think our next focus should be on safety and ease of use. So in particular, when I've been doing these mapping missions recently, I've really missed having like MRTL, do land start or some way to basically get the boat to navigate through a harbor as part of RTL. We have safe RTL, so it will follow its exact path. The outgoing path, it'll use that on its way home. So that is useful, but I think I'd like to have something, and I'm sure that other users would appreciate having support for do land start, or perhaps an ability to execute the mission in reverse to get safely back to home. Object avoidance. So one of the unique problems, perhaps, of trying to do object avoidance on the water is that LiDARs just don't work very well. They tend to hit the waves and bounce back, and then you get all these false positives. So we should add support for more radars, and which bounce off the waves. We should also make sure that we've got a really robust AI camera-based object avoidance solution. So Rishab has done a bunch of work in the copter area. I'd like to extend that to so that it can recognize the kinds of obstacles that a boat would see, rocks and other boats and things like that. And we should also consider adding support for avoiding manned boats whose position has been provided by the AIS sensors.
Randy?
Yeah.
Tom Pittenger here. I think there is support, or there's a pull request by Peter to do the to treat AIS like ADSB, so it does automatic boat avoidance.
Yeah.
I think that's a lingering PR at this point.
Yeah.
Available.
Yeah, I think it's tricky. I think it's maybe. I think yeah. I think it's going to have. I think it's going to be a fair bit of work actually. And I know that Rishab has done some work on sort of a real-time Dijkstra's or real-time A-star, and I think that's probably what we need. Bendy ruler could also work, but in my, I'm not sure. Bendy ruler might work. I'm not sure.
Am I audible?
Yes, you are.
Hi, Randy, Rishabh here. So I was actually thinking, can't we just sort of treat it as an object in the object database as of now, and then see where it goes from there, so that at least Bendy ruler can use it?
Yeah, I think that's the first, a good first step. I think that the problem is just that these man boats are very large, or they can be very large, and you don't want to come at all close to them. So, in my personal experience anyway, Bendy ruler, we've used it to get, around obstacles that are quite close to the vehicle. So, you avoid that obstacle by 1 meter or 2 meters. And I'm sure we have, configuration, which can make us avoid it by much larger margins. But, you certainly wouldn't want to come 10 meters, within 10 meters of a man boat. You'd want to miss it by a kilometer or something like that. So I think the scale is quite different. And I'm not sure if our Bendy ruler as is going to handle that properly.
Well, I remember the Bendy ruler was actually made for planes, which is designed to be larger scale like that.
Yeah, indeed. We are missing, of course, also the velocity component. And Trish just brought this up a couple of times, in that our Bendy ruler in Copter and Rover is not using the velocity of the obstacle. We didn't have any way, we didn't have any source of the obstacle's velocity. We didn't have any source for that before, so we didn't include that in Bendy ruler. With AIS, we do get the speed of the vehicle. So, on this slide back here, you can see it's, this ferry is moving at 3 meters per second. This boat only moves at 3 meters per second. So it's a big, we definitely need to take that into consideration when we're trying to avoid that boat. But yeah, these are all good suggestions though, I'm not saying they're not. I think it's just going to be a bit of work, but fun work. Next one is autonomous docking. So whenever I've launched my boats, there's always had to be 2 people, moving that boat into the water, and also when it comes back, dragging it back out of the water, because they are, 45 or 50 kilograms. So it's, it's not terrible, but it's a bit of a challenge to get in and out of the water. So I think autonomous docking would be a great help. We've got that on the GSOC project list, so I'm pretty confident that'll get done over the next few months. Just another note was Peter Hall showed us a really cool demo, maybe 6 months ago, maybe a year ago, of some work he'd done to extract the shoreline from was it Open Map, something like that. Sort of think that would be interesting to integrate as well. Street map, Open Street Map.
Yeah, OpenStreetMap. Yeah, I'll get back to it.
Oh yeah, no pressure. Okay, great. Yeah, sorry, and a few more things actually that we'd like to work on. Auto tune, that is probably our most requested feature. I find boats really easy to tune, but much easier than copters. But still, for new users in particular, it'd be great to get an auto tune feature added. Cloud integration. because boats collect up so much data and they are traveling for, quite often many hours, they produce massive log files. 1 gigabyte log file is nothing. Automatic uploading of those log files would be great. Also, automatic uploading of the, the sonar logs, which can also be huge, would be great. And remote operation. In Japan, we have the HereLink, which has been a godsend. Gives us at least a couple kilometers of range. But with boats, again, they can go so far. You don't really want to follow them around in another boat. That kind of defeats the whole purpose. So, remote control of boats is more important than perhaps with some other vehicles. Payload integration. I guess this applies to all vehicles, but with boats, the side scan sonar. It's something that I'd like to integrate, especially using the vehicle position. So down on the bottom right here is a side scan sonar output from John Easton's, one of John Easton's posts. So, and you can see there's this little black spot, and that's actually caused because the side scan sonar's GPS was incorrect for 30 seconds or something like that. I suspect that the Autopilot's GPS and position estimate is much better than what these side scan sonar GPSs can produce. So I think it'd be interesting to try and integrate the vehicle position and attitude, et cetera, into the data collected by the sonar. Maybe we could make some cool 3D maps as well. Underwater camera and microphone. I guess that's a lot of submarines. The other thing that we'd like to do is add support for more high-powered motors. So the next one on the list is the e-propulsion motors. I think the Torqeedo motors and the e-propulsion motors are the most popular electric motors on the market. So we've got Torqeedo already, at least for the low-powered Torqeedo motors. Next, I'd like to add support for the e-propulsion. They're very similar, actually. The protocol is very similar. So that should be done soon. And I think that's it. Yep, that's it. Questions, comments, no?
Fantastic. Thanks so much, Randy. So questions? Questions from the floor?
I had a question. Randy, have you thought anything about the boat docking project? Are you thinking of doing it as a companion computer thing, or as a mode, as a specific rover mode that is inbuilt? Sort of like how we do precision landing in copters, or
exactly.
Do it completely off board?
So I'm thinking at the moment that it'll be very similar to precision landing. So I think that we're gonna take the AC precision landing library and turn it 90 degrees essentially, or at least use the mini EKF portion of it. Maybe it'll have to be in a new library. My guess is that it will actually have to be in a new library. But hopefully we can.
It might not be that possible to use the. I mean, it would of course be possible. It might not be that easy to reuse precision landing directly. So we'll have to see on that. But I was wondering if it would just be better to have it as a Lua script or a companion computer script or something.
Yeah, possibly. I think maybe the estimation part at least has to be in the vehicle code. So that, like, precision landing has like two parts. So it has the one part which is, where is the target? And then the next part is how do we get there? And the estimation part, I think we should try and leverage the precision landing's mini EKF. But then when it comes to, how do you dock the vehicle? How do you get the vehicle, 3 meters in front of that target and stopped and facing in the right direction? Whether that's a Lua script or a flight mode, I'm not totally certain yet. I was thinking of flight mode, but I don't think it has to be.
That makes sense. Yes.
Okay. Any other questions? All right. Well, thank you very much.
All right. Fantastic. Thanks so much, Randy. So it was really, really good. Greatly appreciated, and really good to see how far boats have come. So we were scheduled to have another talk today, Nick's talk on ESP32, but he actually had thought it was going to be tomorrow. And so the slot at the same time was actually available tomorrow. So we've just arranged to move Nick's talk to tomorrow, which makes up a little bit for my gross overrun in my talk. And I apologize again for overrunning so far. So if we have a look at where the schedule is now, so that actually means that we've had all the talks for today. So we'd start again tomorrow morning with Ryan Beale's talk about aviation altitude handling. Ryan, are you online? Are you all ready for your talk in the morning? Okay, I might ping Ryan separately, just make sure that he's all ready for that. Followed by Jeff with remote ID and Leonard on advanced guidance, Bill on a heli update, and then Nick with the ESP32 update. Because I overran so far, it actually means we're not far off our planned closing time for today already. So that brings us to the end of the first session of the Dev Conference. So we'll start again tomorrow morning, Canberra time, and people have got some time this afternoon to prepare their talks for the following couple of days. And thank you to all the great speakers today. Really appreciate the talks today, and looking forward to more great talks tomorrow. Speakers, remember to put your slides, a link to your slides up on the Discuss post. That's about it. So thank you all, and we will see you all tomorrow morning, Canberra time.
Thanks, everybody.
Yeah, thank you. And Church, I just talked to Ryan Beale, and he's ready to go.
Fantastic. Okay, thanks, Tom. Great. All right. Well, I'll end the recording there, and then we'll start up again tomorrow morning.
Thanks to all speakers.
All right. End of the meeting. Thanks, everyone.